All right, everybody, welcome to part 3 of the iMessage build. My name is Shadi, and if you are new here, this is part 3 of a multi-part tutorial series I am doing, so please check out part 1. It is available somewhere at the top of the screen. Also, I have a Discord server where you can get direct access to me and to ask any questions about the project or really to just chat about anything. So please do join that. The link is in the description and I would love to see you in there. So just a little recap of part 2. We completed mostly all of the conversation creation process and built a ton of our critical React components. And all we really need to do in order to complete the conversation creation process is to finish writing the create conversation resolver and actually create the conversation document in the database using Prisma. And so in this video, we are going to start to look at how we are going to model the data in our database and look at the relationships between those entities. And we are also going to configure our Apollo server as well as our Apollo client to use a WebSocket connection so that we can start creating the real-time functionality with GraphQL subscriptions. All right, so let's jump right in. So we are pretty much done all of the heavy lifting for creating a conversation on our front end, and what is left is the create conversation resolver on our back end. So let's go into our conversations resolvers file. Currently, we just have this empty function here with this console log. So this is where we are going to save our new conversation to our database when we click this button here on our front end. Now, the conversation entity is going to have some relationships with other entities in our database, such as users and messages. We need to know which users are part of a conversation, and we need to know which messages are part of a conversation. So there's going to be some relationships here going on with the conversation entity. And so before we can actually insert the conversation into our database, we need to make some updates to our Prisma schema so that when we store the conversation in our database, it has the right relationships to the other entities. And this create conversation resolver is actually going to be quite straightforward once we make these updates to our schema, because Prisma is going to make inserting the conversation document into the database with these relationships very easy once we tell Prisma about these relationships, which is what we're going to do in our schema. So let's head on over to our backend schema.prisma file and make these updates. So currently our schema looks pretty much the exact same as it has since the beginning of this app. We only really have the authentication entities. And so now we're actually going to start adding some chat related entities here. So right now we're going to create our conversation model and look at how we're going to introduce the relationship between conversations as well as users so we know who's in what conversations. And then later when we start actually sending messages in the conversation, we will come back here and create the message model and look at those relationships as well. But for now, we're going to focus on the conversation to user relationship. Now, although we are using MonGO, which is a NoSQL database, meaning that we can really model the data however we want, Prisma really shines and is amazing to use when you model your data in a more SQL-like fashion with SQL-like relationships. Prisma is going to make querying our data extremely easy with these types of relationships that we're going to create. Okay, so just underneath our verification token model here, let's create our conversation model. So to create a new model, we're just going to use the keyword model followed by the name of our model, which is going to be conversation. Now, the first field that all of our models are going to need is going to be an ID. And so we can just copy this statement up here from the verification token and just paste it in here. And then I'm just going to quickly declare the timestamp fields that are going to be on all of our entities. So firstly, we have a created@, which is going to be of type date time. We can set a default value using the @default keyword. And so inside of here, we can pass in the default value that we want this field to have. And so Prisma has a function called now that we're going to call. And this is basically just going to create a timestamp that represents the exact time that this document was inserted into the database. Then underneath here, we can add an updated field. This is also going to be of type date time. And Prisma has this very nice updated@ parameter here that we can put, which is going to tell Prisma to update this field every single time a conversation entity is updated. Okay, so these are the basic boilerplate fields that every model in our database is pretty much going to have. So now we can talk about the more interesting ones and look at how we're going to create the relationship between our conversation model and our user model up here. So when we describe the relationship between a conversation and a user it is safe to say that a user can be part of many conversations, right? As a user, Shadi, I can be in, infinitely many conversations with a bunch of my friends. I can have 10 group chats going on. I can have a bunch of private messages, right? As Shadi, I can be in as many conversations as I want. And on the conversation side, conversations can have many users. So we are building our app to support group messaging. Conversations can essentially have infinitely many users. Okay, so since any given user can be in many conversations and any given conversation can have many users, the relationship between a conversation and a user is what we call a many-to-many relationship. And this is an important data modeling concept. When you're modeling relational data, many-to-many is an important concept. Other relationships that you can have are like one-to-many and one-to-one, and many-to-many is the most complex case, but that is what we have on our hands here because we are building our app such that many users can be in a single conversation. We do have this many-to-many relationship here. So when you're modeling data or designing a database of any kind, if two of your entities have this many-to-many relationship, you must create what is called a join table to successfully allow these two entities to relate to each other in this way. So to give like a visual of this join table concept here, I've just created this very simple diagram here. So as I just mentioned, the user and the conversation have this many-to-many relationship. So in order to model that relationship from a database standpoint, we have to create this sort of join table that acts as the middleman between these two entities. In our case, we are naming this entity conversation participant. You can name it really whatever you want, but conversation participant is, I think, a pretty clear name that communicates its job. So we basically have a user table with a primary ID key, and we have this conversation table with also a primary ID. And the way we relate these two entities is with this conversation participant, the join table, with these two foreign keys here. And it's through these two foreign keys that we're able to relate these two entities. So the conversation participant has a foreign user ID key that maps to the primary key of the user, and it also has a conversation ID foreign key that maps to the primary conversation key. And this is how we can create this many relationship between our user and conversation. So in our Prisma schema, we are going to need to create this conversation participant model, and then we can declare relationships between it and the user and it and the conversation in order to establish this connection. Okay, so let's go ahead and do that in our Prisma schema here. Okay, so underneath our conversation model, let's create that conversation participant model. So we can declare that as model conversation participant. And this is also going to need an ID. So let's just grab the ID and do that. So on our conversation participant model, we need to declare these two foreign key fields here, user ID and conversation ID. So let's go ahead and start off with the user. So let's start off with the user ID here. And this is just going to be of type string. And I'm going to just tab this over so these are all kind of aligned. I'm going to do that up here as well. Sorry. So we have created this user ID field, but we somehow need to tell Prisma to create the relationship between this user ID on the conversation participant and the ID on the user. And so basically we are telling Prisma to form this relationship here, represented by this line between the user and the conversation participant. So let's go ahead and do that. Underneath the user ID, we are going to declare a relation field called user, and this is going to be of type user. And the way we can declare the relationship between the conversation participant and the user is by on this user field here, we can use the relation function. And inside of this function here, we need to declare which two fields from both the conversation participant and the user entity are being linked. So the first argument to this function is going to be called fields. And inside of this fields array, we are going to pass in the name of the field on this conversation participant entity that is acting as the foreign key or the link in this relationship. And in this case, the foreign key is going to be the user ID. And as a second argument, we can pass in this references array. And inside of here, we are going to put the name of the field on the user that is the other side of this relationship here. In this case, this is going to be the ID of the user, right? So we're basically saying that the user ID on this entity is linking to the ID of the other entity, right? And that's exactly how this relationship was shown in this diagram. The ID of the user is linking to the user ID of the conversation participant. Okay, so Prisma is angry here, so let's hover over it and see what it says. It's basically saying that the relationship field user on model conversation participant is missing an opposite relation field on the model user. So basically what Prisma is saying that we have declared this relationship between the conversation participant and the user on the conversation participant side, but we have not yet established that relationship on the other side. So it's basically just saying that we need to add the opposite relation on the other entity of this relationship. And so to do that, we can come up to our user model here, and just under our username, we can declare the other side of this relationship by saying conversations, and we can say that this is going to be an array of conversation participants. So basically, this is saying that a user can be part of multiple conversations, hence they can have multiple conversation participant entities, which is why we are declaring it as an array here. So we have successfully linked the conversation participant model to the user model through this relationship here. So we have successfully created this link here. So we just need to create this link here to finish off this many-to-many relationship. And so we can do that doing basically the exact same thing we did here with the user, but with the conversation. So underneath here, we're going to create that conversation ID foreign key, and this is going to be of type string. I'm just going to bump all of these things over. I feel like there's a better way to format a Prisma file. There's probably some like extension or something to do this. Okay, so we have the conversation ID, and then underneath here, we can create the conversation relation field. So we can say conversation, and this is going to be of type conversation. We want to declare this as a relation. The field on the conversation participant that is acting as the foreign key in this relationship is the conversation ID, and this is going to be referencing the ID on the conversation. And so now Prisma is angry about the same exact thing as it was with the user, and so we just need to declare the other side of this relationship on the conversation entity here. So on the conversation, just underneath the ID here, I am going to declare a field called participants, and this can be represented by an array of conversation participants. And so now you can kind of see this many-to-many relationship here. Okay, so a user can be part of many conversations, and a conversation can have many participants or users. We have successfully modeled this many-to-many relationship between conversations and users through this conversation participant join table. And actually, I'm thinking that we should just define our message model as well while we're here in our schema making these changes. I was going to wait until we got into the sending of messages logic to define the message model, but I think we just might as well just do it now to get some more practice with this whole entity relationship modeling with our database here. So underneath our conversation participant model, let's define our message model. So we can say model message, and this is going to have another ID field, just like the other entities. And it's also going to have these two timestamp fields here, created at and updated at. And I'm also going to add these to our conversation participant. Okay, and just format these a bit here. So let's think about the relationship that any particular message is going to need to have with other entities in the context of a chat application. Okay, so when we think about a message, we need to know what conversation that message is part of, and we also need to know who sent that message. So in order to know what conversation any given message is part of, we need to relate our message entity to our conversation entity. So let's think about what type of relationship that is. All right, so a conversation can have infinitely many messages, but a message can only belong to a single conversation, right? We don't want the same message to belong to many conversations. We only want any given message to be part of a single conversation. So the conversation relationship with the message is a many-to-one. Conversation can have many messages, but a message can only be part of one conversation. The same thing is going to exist for the user to message relationship. A user can send infinitely many messages, right? There's no cap on how many messages Shadi can send. He can send 100 million messages if he wants to, but any particular message can only belong to one user. So again, we have this many-to-one relationship between the user and the message. And so we need to define those two relationships on our message model here. Okay, so let's start off with the conversation relationship. So in order to know what conversation any particular message is part of, we are going to need to know the conversation ID of that message. So this conversation ID is going to be of type string. And now we need to tell Prisma to form this relationship between our conversation model and our message model through creating this relation field here. And we're going to call this conversation This is going to be of type conversation. We want to declare this as a relationship. And for our fields value, we want to pass in the conversation ID because that is the field on this entity that is going to be linking to some field on the other entity. And that reference field on the other entity is going to be the ID. So our message model is going to link to the conversation model through the conversation ID on the message and the ID on the conversation. And let's fix this relationship Prisma error here by coming up to our conversation and declaring the opposite side of this relationship here. Okay, so just underneath the ID here, let's declare the many side of this relationship. So we can call this messages, and this is going to be represented by an array of messages. And so this is what is saying that a conversation can have many messages. Okay, so now let's form the relationship between our message model and our user model. And it's going to be pretty much the exact same as the way we just linked our message to our conversations. Okay, so underneath conversation, let's define a field called sender ID, and this is going to represent the ID of the user that sent this message. This is going to be of type string, and then to form the relationship, we want to declare a sender relation field, and this is going to be of type user, and we can declare this as a relation. Our field's value is going to be the sender ID, and this is going to reference the ID of the user. So now we need to go up to our user and declare the many side of this relationship here by saying that a user can have many messages. So we could say this is going to have messages, which is going to be of type message array. So we have successfully linked the message model to both our conversation model as well as our user model. There is just one more small thing we want to add between our message model and our conversation model. On our conversation model, we want to store the latest message that was sent in that conversation. So we are going to introduce another relationship between our conversation and our message models, but this is only going to be a one-to-one relationship because a conversation can only have one latest message, and any particular latest message can only belong to one conversation. So it's just a one-to-one relationship. So on our conversation model, let's define a field called latest message ID, and this is going to be of type string. Then underneath here, let's define the relation field, which is going to be latest message. This is going to be of type message. However, we are going to declare this as optional using the question mark here because a conversation is not always going to have a latest message. When you first create a conversation, it is not going to have a latest message because there are going to be no messages inside of that conversation. So we want to declare this as a relation field, and the field on this entity that is part of this relationship is going to be that latest message ID, and this is going to reference the ID of the message. And so Prisma is kind of freaking out here because we have two relationships defined between the conversation as well as the message. And so to tell Prisma that they are different relationships, we need to give these relationships unique names. And so we can do that by simply adding a name to this relationship here. So we can give this latest message relationship a name of just latest conversation message. So that solved that one problem up here. But now we have that same error that we were having before, where we did not define the opposite of this relationship on the other model here, which in this case is going to be the message model. Okay, so on our message here, we can just create a field called isLatestIn, and this is going to map to a conversation. So we are saying that this message is the latest in some conversation. That is what this kind of means here. And again, we are going to declare this as nullable because it is not always going to exist. So we want to declare this as a relation field. And so since we have those two relationships between the conversation and the model, and we have to give this unique name here, we want to tell Prisma which one of these two relationships that this is part of. So we want to pass in a name, and we want to give it this exact same name here so that Prisma knows what relationship this is part of. All right, so what is going on here? Okay, so it looks like we have two issues here. So basically it's just giving us a warning. Since we have this latest message field declared on our conversation here, we have introduced a cyclic reference. And in most cases, when you're modeling relational data, you don't want to have any cyclic references. But I've read some articles on this topic, and they say that a lot of the times it can actually be quite useful and totally fine to introduce a cyclic relationship, especially in this case here when we want to store the latest message here. Like sometimes you'd want to know like the user's latest action or something, or their latest transaction. And then it can kind of create this like cyclical reference between two entities. And don't worry if this doesn't make any sense at all. It's kind of beyond the scope of this tutorial. I don't want to go too deep into, data modeling, just so that we can keep moving here. But basically Prisma is telling us how to solve this here by using these onDelete and onUpdate functions. Okay, so just after this references array here, let's add onUpdate and make this no action. And we can also add onDelete and also make this no action. Okay, so this should solve the cyclical issue, but we still have an issue here. Oh yeah, this was the second issue. It's saying that a one-to-one relationship must use unique fields on the defining side. So essentially what we need to do here is just declare this latest message ID as unique. And this uniqueness is important in a one-to-one relationship because only one of these entities can map to another single one of the other entity, which in this case is a message, right? There is no many-to-one or many-to-many relationship here. It's a one-to-one, so it must be unique. And one last thing we actually need to add to our conversation participant model here is a Boolean field that is going to tell us whether or not this particular conversation participant has seen the latest message in that conversation. So we can call this has seen latest message. And this is going to be of type Boolean. And this field here is how we are going to add that functionality where the user is going to know which conversations they have read and which ones they have not read. So when a new message comes into a conversation, this is going to be false by default, meaning that that user has not seen the latest message, meaning that it contains a message that is unread. And then when they click on that conversation, we are going to mark this as true, meaning that the user has read the latest message in that conversation. Okay, and I'm just going to format these again here. There's got to be a better way to format a Prisma file that I just don't know about. If anyone knows a better way to format a Prisma file, please let me know in the comments. I will greatly appreciate that. Okay, so that wraps up all of the changes that we are going to need to make to our schema. And so now all we need to do is rerun that Prisma generate command so that the Prisma client is aware of all of the changes we just made and is aware of all of these new relationships we just introduced between our models. And then we can go back to our conversation resolvers and finish writing this create conversation mutation. And we will be able to use Prisma to write the conversation to the database with those new relationships that we just created in our schema. Okay, so let's open up our terminal here and let's go into our backend directory. So I'm going to open a new tab into our backend and we are going to run our Prisma generate command here to create this new Prisma client with all of these updates. So I'm going to run npx Prisma generate, going to use the -- schema flag and point this to the path our schema is in, which is source/prisma/schema.prisma. Run this command and it is going to regenerate our Prisma client. So now Prisma contains all of our latest schema updates, and as a result, it is going to be extremely easy to create entities along with their related entities at the exact same time. So for example, when we create a conversation, Prisma is going to allow us to create the corresponding conversation participants at the exact same time in the same exact database operation. And we're going to see this in just a second here. All right, that is enough talking. Let's go back to our conversation resolvers file here and actually complete writing out this create conversation mutation here. Okay, so let's get rid of this console log. And what I'm going to do is destructure the participant IDs from the arguments. And I'm also going to destructure our session as well as the Prisma client from our context. So session and Prisma. And then the first thing we want to do is our usual checking to make sure that the user is signed in. So we can say if there is no session.user, let's throw a new Apollo error, not authorized. So we only want to allow signed in users to be able to create conversations. Unsure why auto import sometimes does not work. I don't know if I'm the only one that experiences this, but we can import Apollo error from Apollo server core. Okay, so if we successfully make it past this if statement and the user is indeed signed in, we are going to try to create this conversation. So what we're going to do is destructure the user ID off of the currently signed in user. So user, and then we want to grab the ID, just like this, and I'm going to alias this as user ID for clarity. Underneath here, we are going to create a try catch block. This is where we're actually going to attempt to write to our database in the catch block here, what I'm going to do is just throw a console log that is going to say create conversation error. And we want to just log the error. And then if this happens, we want to throw a new Apollo error. And then we can just say error creating conversation. Okay, so let's create our new conversation variable. And this is going to be the conversation that Prisma is going to return to us after it successfully writes the new conversation to the database. Prisma is going to need to communicate with our database, which is going to be asynchronous. So we need to use the await keyword, and we want to say prisma.conversation, and then we want to call the .create function on it. So just like we were talking about in our database design. So when we create a new conversation, we also at the exact same time want to create this participants field, which is going to be this related conversation participant entity here. So in other words, when we create a new conversation, we also need to create a conversation participant for every participant that is in this conversation. So let's go back to our resolver here. So when you are calling this create function on a Prisma entity, we want to pass in a value for the data. This is going to represent the actual data that we are storing in this document. So this is going to be the data that we want to I just spilled my coffee all over the desk. Oh, it's okay though, it didn't get in the keyboard. Okay, intermission. So inside of this data object here is where we can actually set the value of any of the fields that we have declared on our conversation model here. Okay, so what exactly do we want to tell Prisma to create in our new conversation here? Well, we don't really need to worry about these two because these are just default timestamp values that will just sort of take care of themselves. When we're creating a conversation, we are not going to have any messages inside of it, so we don't have to worry about the messages right now. The latest message ID, same thing. We don't have any messages, therefore there's not going to be a latest message. So these two are not going to be important at the time of creation. So really the only one we care about right now is the participants. This is really the only thing we need to put inside of our data object here when we are creating this conversation. So inside of this data object here, let's declare the value for our participants. And you can see TypeScript is auto-completing, and you can see that it is aware that this is going to be of type conversation participant, which is pretty cool. The Prisma client is now aware of all of the fields on all of our entities, as well as their types. So let's set a value for our participants. Now, as I was just saying a few seconds ago, when we create this new conversation, we need to create many conversation participants, right? We want to create one for all of the people in this conversation, so Shadman and LolDude. And so the way we can create several at once is by opening up an object here and by using the create many function from Prisma. Then inside of this object, we want to declare another data object. This data is going to be this array of conversation participants. So the value of the data that we put here needs to be an array, right? If I put Shaddy, TypeScript is going to get mad. It's going to say type string is not assignable to basically an array of conversation participants. So Prisma and TypeScript are aware of the type that we declared over here on our schema, and therefore it's going to make sure that we put in the right type. So if I just put an empty array here, that is going to work because it satisfies the type. Okay, so what is the value of this array actually going to be? Well, we are receiving an array of participant IDs through our arguments, so we know all of the users that should be in this conversation. So what we want to do is take this participant IDs array and transform it into an array of conversation participants. So let's do that. So we can take the participant IDs and we can call the map function to transform this array into some other shape. We want to iterate through every ID in the participant IDs array, and for each one, we want to return an object that matches the structure of a conversation participant. And TypeScript is going to make sure that we do that, right? So if I press Control spacebar here, all of the entities that are on a conversation participant pop up here. So that is pretty cool, right? It knows that I am trying to input data for a conversation participant. So TypeScript is recommending all of these fields here that we can place in our new conversation participant entity. Hopefully you're seeing how TypeScript combined with Prisma is insanely powerful here. Okay, so basically what we want to do is take each ID in this array and store it as the user ID in the new conversation participant entity. So we can do that. And we want to initialize the value to has seen latest message to some Boolean, true or false. And the value we want to initialize this Boolean as is going to be the result of this expression here. is the ID that we are currently iterating through in the participants ID array equal to the ID of the user that is creating this conversation. So basically this is saying that the user who is actually creating the conversation, we are going to mark the conversation as read, which makes sense, right? If you create the conversation, you are aware of the latest updates. Now, for other users who are not the creator of this conversation, this is going to be initialized as false, meaning that the conversation is going to appear as unread, which is exactly what we want. So that is it for the actual data we want to create in this new conversation. As a second argument here, we can use this include keyword to tell Prisma what fields we want back from this newly created entity. So if I go inside of here and press Control Spacebar, we can pick and choose what fields we want back from Prisma after it creates this conversation, and everything that we specify in this include statement here is going to be available on the resulting conversation object here. So basically here, we want to include all of the data that we're going to need on our front end. So when we create this new conversation, we want Prisma to return the conversation participants to us. And then on our participants, we can even specify what fields from those we want returned to us. And for each participant entity, we want Prisma to give us details of the actual user that is associated with this particular conversation participant. So to do that, we can add another include statement inside of our participants and tell Prisma that we want details from our user. And inside of this user object, we can specify which fields exactly from the user that we want. To do that, we can use this select keyword here. And inside of the select statement here, we can specify what user properties from the user model that we want to select here. Okay, so in this case, all we're going to need is going to be the ID of the user. So we can say ID true and username true. And this is how you indicate what fields you want back from your model. Now, in addition to the conversation participants, we also want to include the latest message here. And as we talked about before, when we are creating a conversation here, the latest message is just going to be null. But actually, knowing that it is null is going to be useful in our React app because we can use that information to conditionally render some components, which will make more sense as we build out the front end of our conversation item. Let's specify what exactly from the latest message we want to include here. So let's use an include statement. Inside of here, we want to include details about the sender of this latest message. So we can say sender. So the sender is of type user, so we can pick and choose what fields from our user we want returned here. So let's use the select statement again. And inside of here, we are going to do the same as above. We only care about the ID as well as the username. So ID true, username true. So this completes the entire database operation we need to do to create a new conversation. So I don't know about you, but this is kind of painful to look at. So what we're going to do is basically extract this part out and turn it into a variable that can be reused in other parts of the app. Because in other resolvers in our app, when we're dealing with conversations, we are going to be basically repeating this stuff over and over again. So it makes sense to extract it out, create a variable, and then we can just reuse that whenever we need it. And to do that, we can use what is called the Prisma Validator to basically just create this statement. All right, so let's come down to the bottom here, just outside of this resolvers object. Okay, so we're going to need this in other files, so we're going to export it. So we can say export const, and we are going to call this conversation populated. And the reason we are calling it conversation populated is because when we use this lengthy include statement here, we are including a bunch of additional information. So it's not just going to be the base bare bones conversation that we would get if we just said prisma.get conversation. It is going to be a conversation that is populated with all of this other related data, hence the name conversation populated. And so I hope that that makes sense. Okay, so when we create this object here, we need to make sure that it is actually going to be readable and usable by the Prisma client here. So to create this object here as a separate variable, we are going to use what is called the Prisma Validator. So we are going to say Prisma, which we are going to need to import from the Prisma client, and then we can call this validator function on it. And then we can open up another set of brackets here. Inside of here, we're going to open up an object, and inside of this object is where we are going to specify the include statements for our conversation. Okay, so if you remember from above, when we were creating these include statements here, we had type safety. Remember, we were able to see the structure of the TypeScript types when we were writing these out up here. In order to get that down here, we need to tell the Prisma Validator what type of entity we are actually dealing with here. And to do that, we can pass in a type generic argument here. And the type we are going to pass in here is going to come from our Prisma client. And the type of this is going to be conversation include. Because this variable that we are creating here is representing the include statement of a conversation, that is why we are using this conversation include type here. So the type of this include object here is of type conversation include. So when we run that npx Prisma generate command, Prisma generates a ton of TypeScript types for each of our entities, and some of those types include these include types here, so that we actually have type safety when we're writing out these include statements. So under the hood, that is how Prisma works and how it gives us type safety when we're writing out our include statements here. So basically down here, we are just doing that ourselves. So now that we have this type specified, conversation include, we have access to basically the same type safety that we would inside of an actual Prisma operation, which is pretty cool. Okay, so now we are set up and we can just literally take all of this object here, copy it, and place it in here. Okay, we can save that. And now we can strip this entire thing. And the value of our include here is just going to be conversation populated. And now we can reuse this conversation populated very easily in a very clean way, which is super nice. And so to clean this up even more, we are going to do the exact same thing for our participants here. So up here, let's create a new variable called participant populated. And we are going to use the Prisma validator function here. And the type that we want to pass as an argument to our validator here is going to be coming from, again, the Prisma client, but this is going to be our conversation participant include. And the reason it is conversation participant is because we are dealing with the participants entity here, which is of type conversation participant. And we're specifying the include object here, which is conversation participant include. So just like before, we can take all of this stuff inside of the include here, cut it, and paste it in here like this. Now down here, for the participants include, we can say participant populated, just like that. And this is 1,000,000 times cleaner than what we had before. And this is amazing because we can reuse this and this wherever we want, and we don't have to rewrite these bulky include statements. Ooh, okay, that was a lot of information. Okay, so this Prisma validator thing is, it's a lot to take in, and it's a more advanced Prisma concept, but I really did want to cover it here because I did not want to rewrite this entire include statement everywhere. So I thought it was worth showing you how to do that. So that should conclude all of this stuff with the Prisma validator up here, and we have successfully created these nice reusable include statements. So let's come back up here and finish off this resolver here. All we need to do now is basically just return a value from this createConversation resolver back to our front end. And if you remember, if we go look at our conversation typeDefs, we said that we were going to return the conversation ID of the newly created conversation back to our front end. So let's go ahead and do that. So let's declare the return type for this function here. So since it is asynchronous, we are going to be returning a promise. And the data inside of this promise is just going to be that conversation ID, which is of type string. Now, TypeScript is mad because we have declared a return type. However, we have not returned a value of this type from our function. So let's come down here and do that. Okay, so just underneath this create statement here, let's return an object with the conversation ID inside of it. And the value of this is going to be that new conversation's ID, just like this. Now, one thing you might be wondering is why did we bother with any of this include stuff here if we're only returning the ID of this new conversation, right? Like based on what we're returning here, we really don't need to include anything because the ID is already going to be included on the thing that is by default returned from this Prisma create statement here. And that is a good question. So the reason we care about the entire conversation entity is because before this return statement, we are going to emit a conversation created event using our PubSub mechanism, which we're going to add very shortly here once we configure our server to use WebSockets. Then we are going to create a subscription resolver called ConversationCreated that is going to be listening to this event. So when this event is fired from anywhere in our application using PubSub, that conversation created subscription function is going to fire, and then that is going to communicate with our React application via WebSockets, which we are going to set up very shortly here. So the reason we need this full conversation entity here with this rigorous include statement here is because we're going to use this conversation as the data payload in this whole event publishing mechanism here. And then this entire conversation entity is going to be picked up in that subscription function and then passed to our client. And our front end client is going to need the full conversation entity with this included information on it, which is why we are doing this in the first place. So that was a mouthful, but basically all I'm saying is that we are only returning the conversation ID here, but we are going to pass this full conversation entity as the payload in this event here. Okay, so if we go back to our front end modal component here, which is this thing over here, we are already able to fire this create conversation mutation. And now that our resolver has been successfully written, let's give this a go and see if we can indeed create a conversation. So I'm going to open up the database in a second here to see if the data gets stored in there. And then I'm also going to add this log here. Here is data, and make sure that we do get that conversation ID back. Okay, so our loading state is all set up. It's passed into our button. So we should be able to just go ahead and click this button and see what happens. Okay, error creating conversation. So at least our error is working. That's good. What is this saying here? Error creating conversation. So what happened? Let's go look at the backend here. What is it saying? TypeScript cannot read properties of undefined reading map. Okay, so if we go back to our resolver here, we are mapping through the participant IDs. And so I'm guessing that this is saying that participant IDs is undefined, which is strange. Okay, so I checked our front end and the IDs array is successfully being created. I realized I did something really stupid, and we just have a very simple typo here. In this argument type here, I called this participants ID with an S, but it should actually just be called participant IDs. We don't need the S on the participants here. So if we go to our conversation typeDefs, we have declared that as participant, not participants. So that is my fault. So I'm just going to remove this S here and do that. And we just have to change these here, participant IDs. I'm sure some of you caught that and you're like, oh, when's he gonna find out that that is broken? Okay, so now if I'm just gonna clear the console here. If I run this should work here. So create conversation. Awesome. Okay, so I think that worked. We don't have an error. Open this up, and you can see that in the return data, we are getting a new conversation ID. So that seems to have worked. Let's open up the database and see what we have here. Go into iMessage GraphQL. So you can see that 2 new models have been created here, which is good. So if I go into conversation, so we can see this new conversation with this ID that ends in CE1B, which is the thing we're receiving on our front end over here. We have the created at and updated at stuff. There's no like latest message ID or anything because we don't have any messages in this conversation. So this is the exact behavior that we were expecting. And if you go into conversation participants, you can see that there are 3 conversation participants that have been created, and they all have this conversation ID of the newly created conversation. So that relationship exists. So that is really, really cool. So this conversation participant at the top here, this must be the user ID of the user I am currently logged in as, which I forget the username. Is it Shad Bud? I can't keep up with my silly names. I forget them sometimes. Anyway, so I am Shad Bud currently logged in. So I'm 465, right? So go back to conversation participant. This user ID, so this participant here with user ID 465, you can see that the has seen latest message field is true because I am the creator of this conversation. There are no new updates that I'm not aware of. However, for these 2, has seen latest message is false. So on the front end, this is the field that we are going to use to determine whether we need to show that that unread icon, like the little purple dot that says that this is unread. That is how we are going to do that. We're going to say, if this user has not seen the latest message, indicate to them that there are updates in this conversation that are unread by showing them this purple dot. So hopefully that is starting to make more sense how we are going to do that. Very, very cool. We have successfully been able to create conversations and conversation participants with the relationship between them as well as the user. So now that we have successfully been able to create a conversation and return the ID of that new conversation to our front end, which we are seeing in the console here, we can use the Next.js router to add this ID to the URL here, so that our React application knows what conversation the user is currently looking at, and that is how we can query for messages in that particular conversation. So there's a few updates we have to make to our front end here to bring in the next router and redirect the user to this conversation here with that ID. And now that users can create conversations, we actually want to add the conversation query so that we can fetch all of the conversations that this user is a part of and display them in this left-hand side column here. So inside of our modal here, right after we call this create conversation, we want to take that conversation ID and add it to our URL query parameters here using the Next.js router. So after we call this mutation, we just want to do a quick check to make sure that data was successfully returned to us. So we're going to say that if the data returned to us is null or undefined, then we are going to want to throw a new error that is just going to say failed to create conversation. If we make it past this if statement here and data is indeed successfully returned to us, we want to grab the conversation ID off of that data. So we're going to destructure the create conversation object, and then inside of that, we're going to destructure the conversation ID. And so we want to take this conversation ID and add it to the URL query parameters here. And we are going to do that using the Next.js router. All right, so let's come up to the top of our component here. So just underneath our session destructuring here, I am going to create the Next.js router, and we're going to get this from the use router hook. So that is going to import from next/router. And then using this router, let's come back down here, and we want to use our router to push this new conversation ID to the URL query parameters. So we can call this push function on the Next.js router, and to add a query parameter to the URL, we want to tell Next.js that we are adding a query parameter, so we can use the query object. And inside of here, we just want to pass in the conversation ID. And after pushing the conversation ID to the URL, we want to clear the state of our modal and then close the modal. So I'm just going to add a comment here that says clear state and close modal on successful creation. And then what we're going to do is set our participants to an empty array. We want to set our username field to just be an empty string. And then we want to call our onClose function, which is going to close our modal. And I'm just going to get rid of this console log here. Okay, so let's test out this flow. So I'm going to create a new conversation with just lol dude. Select. What should happen after getting a successful response from this mutation is the ID of that new conversation should be put into the URL query parameters here. So let's see what that looks like. Awesome. So the mutation worked, and you can see that in the URL, we have conversation ID is equal to the ID of that new conversation. And so now we can use this conversation ID query parameter in other parts of our React app to know what conversation the user is currently looking at. One of the main components that is going to be very interested in this conversation ID is going to be our feed wrapper here, because it is going to use this conversation ID to actually fetch the messages in that particular conversation. Okay, and I know we have not actually created messages yet, but let's come back to our feed wrapper component and just use the conversation ID and actually just display it on the screen here, just so that we can have more than just this feed wrapper div here. So we'll build out a little bit more of the skeleton of this component. Okay, so at the very top of this component, I am again going to bring in the Next.js router so we can use the use router hook. And then I'm going to grab the conversation ID off of the router query parameters. So I can say router.query, and on the router query object, we want to grab the conversation ID query parameter. All right, so let's get rid of this dummy div here and create a more meaningful component for our feed wrapper. Our feed wrapper is going to be a flex component from CHAKRA, so make sure that imports. And inside of here, I'm just going to temporarily show the conversation ID so that we can actually see it showing up in the browser there. Now, inside of this flex box here, I'm going to add a ternary operator that is going to check if we do have a conversation ID in the URL. And if we do, we are going to show the message feed for that conversation. And if there is not an ID in the router query parameters, that means the user is actually not viewing any particular conversation. So they would just be at like the localhost base domain here. And if that is the case, we want to show some sort of component that says that no conversation has been selected. So let's check for the existence of a conversation ID. If there is a conversation ID, we are going to show the message feed, which is going to be represented by another flexbox. If there is not a conversation ID, we're going to create a separate component for this later. But for now, I'm just going to say no conversation selected. So let's just add a border to this outermost flex container so we can see what we're doing here. Okay, so it currently has no width. It's just a line. So let's make the width of this equal to 100%. So now we can see that that is going to span the entire area that is available. And we're going to make the flex direction of this container equal to column so that our messages display like they normally do in a feed in like a vertical fashion here. Now, the visibility of this feed wrapper component is going to change depending on the device or screen size that the user is on. On mobile screen sizes, we only want to show this component if a conversation has actually been selected, meaning that there is a valid conversation ID in the URL query parameters. And on desktop screen sizes, we always want to show this component. So what we're going to do to get that behavior is add a media query to our display CSS component here. Now on base or mobile screen sizes, the value of our display is going to change depending on whether or not there is a conversation ID in the URL. So we're going to add a ternary operator that says, is there a conversation ID? If there is, let's make the display of this component flex. And if there is not, we are going to make the display none. So on mobile screen sizes, if there is no selected conversation, we are not going to display this component at all, which makes sense, right? If you think about what a chat app looks like on a mobile device, you do not see the feed when you're looking at your conversations list, right? You only see the feed when you click on one of those conversations. However, on desktop devices, we want to show this component all the time. So we can just say on medium screen sizes and up, let's make the display of this component flex. So the most interesting part of this entire component here is going to be this flex container here, because this is what is going to contain all of the messages within this conversation. However, since we have not yet gotten to the message creation functionality of our app yet, I'm just going to display the conversation ID in this component for now. All right, so I'm just going to remove this border here. And for now, we are done with this feed wrapper component. So let's close this. And now we're going to turn our attention to this conversation wrapper component and actually write the query and fetch all of the user's conversations. Okay, so for this new conversation query we are about to create, let's head on over to our conversation typeDefs file and get our GraphQL API all set up with this query. And then we will go back to our front end and actually execute the query. Okay, so let's start off by declaring a new query. Now the name we are going to give the query that is responsible for getting all of the user's conversations is just going to be called conversations. And this is going to return an array of all of the user's conversations. So we can specify that the return type is going to be an array of conversations. So now we actually need to declare a type definition for our conversation entity. So just above our query here, let's create a new type, and this is going to be called conversation. Now, the structure of this conversation type that we are declaring here, we want to be the same as the structure of our conversation populated entity that we declared over here, because our GraphQL API needs to know the structure of the data that is going to be flowing through the network. Okay, so let's come back to our typeDefs here. So our conversation is going to have an ID. This is going to be of type string. It is also going to have a latest message property, and this is going to be of type message. And we're going to need to declare this type in the message typeDefs eventually. We are also going to have our participants array. So we can say participants, and this is going to be an array of participant entities, which we're going to need to create in just a second here. And we also need to declare the two timestamps. So the created at timestamp, which is going to be a date, and the updated at timestamp, which is also a date. So if we tried to query for this entity, we would get some weird error with this date type here. We have to declare what is called a scalar type for our date. Out of the box, I guess GraphQL does not have a date type. So in order to actually use dates and timestamps in GraphQL, we need to declare a scalar called date. And this is as easy as just using the scalar keyword and then declaring the date scalar. Okay, so on our conversation, we have a few types that we have not yet declared. So we do need to declare these. Now, since we haven't gotten to the message functionality yet, we're just going to leave out the latest message for now. But let's declare this participant entity down here. So you can say type participant. So our conversation participant entities have an ID. This is of type string. And if you remember from the conversation populated entity, when we query for a conversation, we are also going to include the user that is associated with that particular participant entity. That is what we were doing in our conversation resolver here with this conversation populated. If we go down and look at this just once again, you can see that for the participants, we created this participant populated entity, which is including the user associated with the participant entity. So our participant entity is going to have a field of user, and this is going to be of type user. And we're going to need to go back to our user typeDefs and declare this entity as well, because I think we only have a searched user declared. We need to go and declare the actual user. And the last thing this entity is going to have is that has seen latest message Boolean. Okay, so let's quickly go back to our user typeDefs and create that type for our user. So I'm just going to split screen these for a second here. So we currently have this search user type. Above this, I'm going to create the actual user type. So again, if you look at the structure of the user in our database, we have all of these properties: ID, name, email, email verified, image, and username. So let's declare those. So we're going to have an ID of type string, a username, also of type string, an email, also string, lots of strings. We have the email verified property. This is going to be a Boolean. The user also has an image, and this is just a URL. So I'm just going to declare this as string. And we're missing one. Oh, we're missing the name. And I'm just going to declare that underneath ID here. And that is also of type string. Perfect. So now we've created the user type, and we can now successfully use it over here in our participant type. Okay, so let's close this. So I think this is all we need to do for our typeDefs for now. If we're missing anything, I'm sure we will find out by getting some error when we try to perform this query. But I think we are good to go for now. And like I said before, we will come back to this latest message field when we have message functionality built into the app. All right, so the typeDefs are done. Let's go to our resolvers. And in this resolvers object here, let's now create the query section. And inside of the query section, we want to create the conversations query resolver. And we can declare this as an asynchronous function, just like this. And inside of here, let's just log conversations query. All right, and let's just quickly add in the resolver arguments here. So I'm just going to copy them from down here, paste them. So for our conversations query, we are actually not going to be getting any arguments. So we're not going to need args. So I'm just going to declare it as a double underscore because we already have used underscore up here. And since we're not using this, I'm just going to make the type any. And this resolver is actually going to be very straightforward. All we need to do is find all of the conversations that the currently signed in user is a part of. So we can use the user ID from the user session and perform that query quite easily. All right, so now our backend is set up to accept requests for this conversations query. We have the typeDefs declared, and now we have a resolver function. So let's go back to our front end and make sure that we're actually hitting this resolver and that we can see this log, and then we'll come back here and then build out the rest of this resolver function. Okay, so let's switch back to our front end and go into our conversation operations file here and declare the query string for our conversations query. Okay, so inside of the query section, let's create the conversations query, and this is going to be a GraphQL string. So we can use GQL with the double backticks. Inside of here, we are creating a new query. So we want to use the query keyword. The name of our query is conversations, and then we can specify which resolver we actually want to hit on the back end, and that is going to be the conversations resolver. And now we just have to indicate what fields we actually want to query for. So again, going back to this whole conversation populated thing, I mentioned that the reason that we have this include statement in the first place is because we need that conversation information on our front end to do some stuff with it in our React components. So from our front end, we want to make sure we are indeed querying for all of that information. So we are going to want the conversation ID. We also want to query for the conversation participants. I have such a tough time typing this word. It's just like an awkward word to type for me. On each participant, we want to query for the user field. And on the user field of each participant, we want the ID as well as the username here. And I think this is our first time querying for nested object properties here. So you can see that on the participants, we are querying for the user. Then on each user, we're querying for the ID and username properties. And so in GraphQL, this is how you can query for nested object properties. And on our front end, the ID and the username are really the only two user properties that we care about and that we're going to need in our React components. And that is why in this participant populated entity, we were only selecting those two fields. So hopefully you're starting to see how the front end and the back end are sort of tying together through GraphQL. And the other thing we want to get from each participant is that has seen latest message Boolean field. Another conversation property we want to query for is the updated at field. And the reason is because we want to be able to sort our conversations by the updated at date. We want to put the ones that were most recently updated at the top. And actually one last thing we want to query for here is going to be the latest message field. And on the latest message, which is going to be of type message, we want to query for the ID as well as the sender of that message, which is just a user. And the two properties we care about of the sender are going to be the ID and the username. And we're also going to want to query for the message body, so the actual text of the message, and we want the createDat field as well, so that we can display the time at which this message was sent. So these are all of the conversation properties that we want available to us on our front end. So this is kind of long. So what we're going to do is actually extract it out and create a reusable ConversationFields variable, because in other queries and mutations and subscriptions, we are going to be querying for these exact same fields on each conversation. So we're just going to strip this out and create a reusable variable. And it's very simple to do that. At the very top here, I'm just going to create a variable called ConversationFields. And this is just going to be a string that we can create with backticks. And inside of here, we just want to paste this entire query string. So paste that in there like this. Doesn't seem to want to auto format. And then to use this ConversationFields variable down here, we can just open up a template literal variable here with the $sign and curly brackets, and we want to pass in the ConversationFields query string. Awesome. And so now we can reuse this ConversationFields variable in a bunch of other operations as well, which is super nice. And we don't have to retype this every single time we're querying for a conversation. All right. I feel like my voice is getting deeper as I get further into this recording. My throat's kind of getting sore from talking so much. I don't know if you can notice a difference in my voice, but it feels like deeper to me. But we're going to power through this conversations query because we must. Okay, so I'm actually not sure if we're going to get an error querying for the message properties here, since we don't have message functionality yet built into our app. But we might be okay because the latest message might just be null, but we will see. We'll try to perform the conversations query with the fields as they are currently. And if we run into issues with the message, we'll just strip this out and then add it back later. Okay, so now let's actually go into a React component and execute this query. The component that we are going to perform this query in is going to be our conversations wrapper. And at the top here, let's bring in our useQuery hook from Apollo client. And we want to pass in our conversations query string that we just created. So let's import our conversation operations at the top here. So import conversation operations from, go up 3 directories into GraphQL, operations, and then conversation. Okay, and then as an argument to our useQuery hook, we can pass in conversation operations dot queries dot conversations. And as usual, the 3 values we're going to get from this hook are going to be data, error, and loading. And later on, we are going to have a few other queries and subscriptions defined in this component. So I'm going to alias these names to be specific to this query, just so we don't have any name conflicts later on. So data, we're going to call conversations data. Error is going to be conversations error. And take a stab and guess what loading is going to be called. Conversations loading. Cool. Okay, so to help see if this is actually working, let's log this data here. Here is data. And there is no data because I just aliased the name, conversations data. And okay, I think it's breaking here. I think this error has to do with this query, but let's refresh. So so I think that query is broken. But basically the query is going to fire as soon as this conversations wrapper component renders, because that is how the useQuery hook works. If you remember, I was comparing useQuery to useLazyQuery, and I was saying how useQuery fires as soon as the component renders. In this case, we want that behavior, right? As soon as this component renders, we want to go ahead and fetch this user's conversation. So useQuery makes sense here. All right, so we are getting an error saying bad request. What is happening? I think, is our backend broken or... Okay, our server is not dead. So let's check the network tab here. Let's zoom out a bit. So we got a 400. Just gonna expand this a bit. Okay, so if you look at the errors here. Okay, yeah, so I think we're running into errors with this latest message. So it's saying, cannot query field latest message on type conversation. Okay, so yeah, what's happening here is on our front end, our query string does contain the latest message property. So we are trying to query for the latest message. However, on our typeDefs, I think we commented it out. If we go back to our conversation typeDefs, Okay, yeah, so we commented this out, but if I bring it back in, we're still going to get an error because we have not actually defined the message type yet. Maybe we should just do that. Okay, so we might as well actually just declare this message type now. It's not that hard. It's a pretty simple type. It's like it has like 4 properties. So yeah, let's just do that now. We might as well. Okay, so inside of typeDefs, let's create another file called messages.ts. And inside of here, we are going to create our message typeDefs query string. So we can use our GQL function from Apollo Server Core. And the only type we are going to declare right now is going to be the actual message type. And this is going to have an ID of type string, a sender of type user, a body, which is string, as well as a created at, and this is going to be a date. And then we just need to export this, so we can say export default typeDefs. Okay, now to actually add this to our GraphQL schema, we need to go into our typeDefs index file here and import our message typeDefs from messages, and then we can just add it to this typeDefs array here. Message typeDefs. So if I save this, hopefully the server does not die. Okay, so it's live, the server's started. Okay, so now that we have created this message type and it is included in our GraphQL schema, we can now use it in this conversation typedef over here. So let's close messages because we're not going to use that for a while. Close the directory here, and let's go back and try to perform this query again and see what happens. Refresh. Okay, so we did not get an error that time. So yeah, that was the problem. Okay, so if I just look at the response here, we're not getting anything back. We're just getting null because we have not returned anything from our conversations query resolver. But at least we know that it is working and we are hitting the server. So I think we have a console log there. Yes, so we were logging conversations query in the conversations query resolver. And so we are successfully hitting that resolver from our front end. Okay, so let's go back to our conversations wrapper component. Okay, so our query is successfully connecting to our API. So let's just quickly make this query type safe by adding in the 2 types for the structure of our data that we're going to get back, as well as the arguments. So let's go into our front end types util file here. And just underneath this conversations comment here, let's create the interface for our conversations query data. So we can say export interface, and we are going to call this interface conversations data. The data we are going to get back is going to have a conversations key, and this is going to map to the structure of the data, which is going to be an array of conversations. But we have not yet created a TypeScript type for our conversation entity. We only created the GraphQL type in our conversations type definitions. We have not yet created a TypeScript type for our conversation. And similar to our typeDefs, we built the structure of this to match the structure of our conversation populated structure. So we're going to do the exact same thing with our TypeScript type here. So basically what we want to do is create a TypeScript interface that is going to have the exact same structure as this conversation would if you were to include this conversation populated include statement. So if I hover over this, you can see the type of this, and you can see that it says conversation and participants and all this stuff. So basically we want to create a reusable TypeScript interface that has this exact structure here. So again, we can use Prisma to generate a TypeScript interface of a conversation that would have this particular include statement here. So let's head on over to our backend types util file here. And inside of here, I'm going to create a new comment that says conversations. So we sort of have a conversation type section. So our goal here, like I said before, is to create a TypeScript type that has the same structure as our conversation populated entity. So we are going to use this in other files across our app. So we are going to export it. We are going to create a type called conversation populated. And this is where we are going to use this conversation populated entity that we created with the Prisma Validator to generate a TypeScript type. And so the way we can do that is by, again, using this Prisma object from Prisma client. So make sure that imports. And we want to access a type on here called conversation get payload. This is one of those types that is generated when we run the npx Prisma generate command. This specific one here, conversation get payload, allows us to do exactly what we're trying to do here, which is creating a TypeScript type for a particular Prisma query. So we can open up a set of angle brackets here, and inside of here, we can specify which exact Prisma get operation we want to generate this TypeScript type for. So if I press Control Spacebar, you can see what TypeScript is allowing us to do here. And since we are dealing with the conversation include statement here, we want to indicate the type of our include. And the type of this include value is going to be the type of our conversation populated entity. So what we just did is we generated a TypeScript type that would have the structure of a conversation if we were to query for it using this particular include statement, which is exactly what we are doing over here and which is what we are going to do in all of our conversation queries. And this is super useful because this is going to be the type of all of the conversation entities throughout our application. So just like on our front end, if you go back to our front end util types file here, now we have a type that we can specify here in this array. So now we can declare this as an array of populated conversations. So we can say array of conversation populated, and it does not want to auto import for some reason. So let's come up to the top here, and we want to import this type from our backend directory. So we want to go all the way up 3 directories to our backend, into source, into util types, and from that file, we want to grab that conversation populated type. So now we have an interface that describes the structure of the data we're going to get back from our conversations query. And one thing I want to touch on is if we go back to this file here, our backend util types, we declared this as a type and not an interface because we are equating it to the type of something else. If you're using the equal sign here, we cannot declare this as an interface. So we're just going to declare this as a type, just like that. And while we're here, we might as well just very quickly declare the TypeScript type for our participant populated. So we can say participant populated is equal to Prisma dot conversation participant get payload. It's kind of a mouthful. And then inside of here, we can pass an include, and the type of this is going to be the type of participant populated. Cool. Okay, so we're done with this file for a while, so let's just close the backend types. Cool, so now we have this conversations data interface here. So let's come back to our conversations wrapper, and we can pass that as an argument to our useQuery hook here. So we can say conversations data, and the second type argument that we pass to our useQuery hook is going to be the type representing the structure of the inputs that we're passing to our query. However, we are not passing any inputs to this query, so we can just declare this as null. So now that we have created those types and we can obviously successfully communicate with our conversations query from our front end, let's go back to our backend conversations resolvers and finish writing out this conversations resolver here. So let's remove this console log here, and like usual, let's destructure a few things from our context. We are going to want to grab our session as well as the Prisma client. And like usual, we want to make sure that the user is indeed signed in before allowing them to access this resolver. So if there is no session.user, let's throw a new Apollo error that is going to say not authorized. So if the user is signed in, we want to grab the user ID off of the session. So let's destructure the user, and on the user, let's destructure the ID. And I'm going to alias this as user ID. Okay, then underneath here, let's create a try catch block. In the catch block, let's console log the error. So we'll just say conversations error, and we will log that out. And then we will throw a new Apollo error with the message from the error dot message. And then we can just declare this as type any, like usual. Now inside of this try block, all we need to do is use Prisma to query for all of the conversations that this particular user is a part of. Now, when I was building out the demo for this app, I wrote the query that would do exactly that. However, I was running into some issues where the query would just not work. I'm going to paste that query in here with some stuff commented out because there's some important things I have to say about it. Okay, so this is the query here that should do exactly that. It should find all of the conversations that this user is a part of. So the idea was to query the conversation model on the Prisma client and call the find many function on it, and then essentially find all of the conversations that have participant entities where the user ID of that participant is equal to the ID coming from the session here. So something interesting happened to me when I was trying to build this out, and essentially it just was not working, and I could not figure out why, because I was doing exactly what the Prisma documentation had suggested to do for this particular situation. So I went into the Prisma Slack and I posted a question in there asking like what the problem was, because I was like, this is what I'm trying to do, and this seems to be exactly what I should be doing. And a support engineer on the Prisma team actually confirmed that this is indeed the correct query and that it also was not working on his end. And so he suspected that it actually was a bug in the Prisma Mongo adapter. So I just wrote this comment here to briefly explain what happened and my findings. And unfortunately, this query just does not work, and it seems to be a Prisma bug. So the support engineer advised me to open up a bug report for the Prisma library so that they could look into it further. Okay, and I just wanted to say that because this would be the query we would be using to do the logic that is required by this resolver. However, we have to do something slightly different because this query does not work. Okay, so what we're going to do instead to work around this is essentially just query for all of the conversations in the database, and then we're just going to use the JavaScript filter function to only return the ones that belong to us. Unfortunate that we can't do this at the query level, but whatever. So I'm just going to make a quick comment here that says, since above query does not work, that is why we are doing the below. So essentially, the value of this conversations variable is going to be every single conversation in our database. So what we're going to do is return a filtered version of this conversations array. So we're going to say conversation.filter, and we want to iterate through each conversation. And essentially, we want to filter out all of the conversations that do not have a participant with a user ID that is equal to the ID coming from the user session. So we can say conversation.participants.find, and we're going to see if any of the conversation participants have a user ID that is equal to the user ID coming from the session up here. And the filter function requires a Boolean result, so we can just Booleanize the value of this find function here by just adding the double bang operator here. And so this is going to filter out all of the conversations that do not belong to this particular user. And note that we are adding this include statement here so that our conversations have that populated structure. Okay, so the very last thing we have to do is just specify the return type of this function. So since this is asynchronous, we are going to be returning a promise, and the data inside of this promise is going to be an array of populated conversations. So we want to bring in our conversation populated type from our util types file and save that, and we should be good to go. And so that is it for this resolver. We should now be able to come back to our browser, refresh this page, and see some actual proper data come back. Cool. So so we are actually seeing this array here. So we have conversations, we have this array, and we have both conversations that this particular user is a part of. Cool. Yeah. So our latest message is null. So we didn't have any issues querying for latest message. And you can see that the type of this is that conversation populated type. Okay. So this is really cool because if you look at this participants array, you can see that we have all of these conversation participants, and then they have the corresponding user, and we have the username and ID for all of these users that are part of this conversation. Cool. So let's just bring this down a little bit here. Zoom out. So now that we have the conversations that this user is a part of, we can build out the conversation item components that are going to be displayed on the left-hand side here that are going to allow the user to actually navigate through their conversations. Okay, so what we're going to do is quickly create the component skeleton for our conversation item component that is going to be displayed here. And then we're going to set up our Apollo server and Apollo client to use WebSockets so that we can start to work on the real-time functionality of our app with GraphQL subscriptions. And then once we set up our server to use WebSockets, we are going to create our first GraphQL subscription, and that is going to be the one called ConversationCreated that I was sort of alluding to down here. And then we're going to start to see some real-time functionality where new conversations for users will appear in real time as they are created. All right, so let's head on over to our conversation list component, because this is where we are going to create the conversation item component. So currently we are not passing the conversations as a prop to this conversations list component. So let's go up to the parent of this component, which is, I think, the wrapper. So let's pass this conversation data to our conversation list. Okay, so let's declare that prop for our conversations list here. So we're going to call this conversations. And this is going to be the conversations data dot conversations. And since the value of this is going to be undefined before the data is actually fetched from the API, we are just going to pass in an empty array if this value does not yet exist. Okay, now let's go back to our conversation list component and declare that prop on our interface here. So we're going to call this conversations, and this is going to be an array of conversation populated. So again, we are using our new conversation populated interface here. Let's come down to the props here and destructure these. And now let's come to our file explorer here. And inside of the conversations directory, let's create the conversation item component, conversationitem.tsx. Let's use our snippet here and do our usual converting to an interface stuff. Remove the React import, close the directory here. So this component is eventually going to take in quite a few props, but for this very simplistic version of this component that we're going to build right now, we are just going to focus on the actual conversation itself. So each conversation item is going to take in a conversation, and this is going to be of type conversation populated. And later on, we will add more props to this interface here, but this should be good for now. So let's destructure the conversation here. And for our very basic version of this component, I am just going to declare this as a stack and display the conversation ID in here for now. Let's come back to our conversation list. And just underneath our modal here, we are going to iterate through all of these conversations and create a conversation item component for each one. So let's say conversations.map. We want to take each conversation and for each one, create a conversation item component. And the prop we want to pass in is going to be the conversation we are currently iterating through. And I think we're just getting an error here because we're missing a key. Yes, so since we are mapping through an array here and creating a React component, we need to pass in a key. And the key we can just make the conversation ID. It is going to be unique. Okay, so let's refresh to just get rid of that error. I don't fully know why there is no IDs showing up here. We should see them. Conversation item. In the item, we have the ID. Why is nothing happening here? Let's log the conversation. Why is the ID not showing up here? I'm wondering if it has to do with some sort of CSS conflict here. Okay, so there, oh, okay, you know what I think it is? Actually, I don't know what it is. Let's try wrapping this. Let's try creating a text component and putting the conversation ID in there. There we go. So we just had to wrap the conversation ID in this text component here. So now with this very basic conversation item component, we can see all of the conversations that this user is currently in. So just to make this look a little bit better, I'm just going to quickly add a padding of 4, so we have a little bit of spacing there. And then I'm just going to add some hover styling here using the hover pseudo class. And on hover, we're just going to make the background white alpha 200. Cool, so that's looking pretty good. And then we can just remove this border here. And we can just add a border radius of 4. So now we have this nice border radius and this nice hover state. So I'm just going to remove this console log here. And for now, we are just going to leave our conversation item component looking exactly like this. And we're going to turn our attention to getting WebSocket set up. And once we create that conversation created subscription, we will then come back here and finish building out our conversation item component. So in order to get our application successfully set up with WebSockets, we need to make quite a few adjustments to both our Apollo client in our front end, as well as to our Apollo server in our backend. And we're going to start off on the Apollo client side. And once that's all done, we will go back to our backend and set up our Apollo server. So to get our Apollo client all set up, let's do a quick Google search for Apollo client subscriptions. And we're going to go to this documentation here in Apollo GraphQL. And let's expand this out. So essentially what we're going to be doing in our Apollo client file here is exactly what they're doing in this documentation here. They basically just go through what libraries you have to install and how you set up the WebSocket transport and creating the actual WebSocket link, et cetera, et cetera. And so we're basically just going to be doing exactly this. And even down here, they have a full code example of pretty much exactly what we're going to be doing. But essentially, all they're doing here is creating this WebSocket link and then creating what is called a split link. And they're taking both the WebSocket link and the HTTP link, and creating this split link so that the Apollo client can determine which GraphQL endpoint to use depending on the type of request that our client is making. So for any HTTP requests, like our conversations query or our search users query, the Apollo client is going to use this HTTP link. But for any WebSocket requests, so any of our real-time functionality, like sending a message or the ConversationCreated subscription, the Apollo client is going to use this WebSocket link. But basically what we are doing here is creating two different endpoints that our Apollo client can reach out to depending on the type of request. And then we are just creating this split link here so that our Apollo client can use both the HTTP link as well as the WebSocket link. So something we're going to need to do on our Apollo server is actually create this subscriptions endpoint so that our client has a valid endpoint to reach out to on our API. But we'll get more into that once we get into the server. So I'm just going to shrink this down a little bit. So since we are using Next.js, we're going to have to make some modifications to our WebSocket link due to the server-side rendering pattern of Next.js. So essentially all we're going to need to do is make sure that the window object is defined, meaning that we are indeed in the browser and we're not on the Next.js server doing server-side rendering before we create our WebSocket link. Okay, so the first thing we're going to need to do is install this package here, GraphQL WebSockets. So let's copy this command. And let's open up a new terminal in our front-end directory and paste that command in there. Perfect. Very quick installation. Then let's come over here and create this new WebSocket link. And like I was just saying, to make this work with Next.js, we want to check that the type of our window object does not equal undefined. So we want to make sure that we are indeed in the browser and not on the Next.js server. If that is true, we want the value of our WebSocket link to be exactly what they're doing in the documentation here. So we want this to be a new instance of a GraphQL WebSocket link. And that doesn't seem to want to auto import. So let's come up to the top here. And I'm just going to copy these two import statements here from this documentation code. And just like the documentation, we want to pass in this create client function. And as an argument to this, we want to make the URL equal to the endpoint that our subscriptions API is going to be available. So I'm just going to copy this from the documentation, paste it in here, and I'm just going to change this from localhost 4000/subscriptions to localhost 4000/GraphQL/subscriptions. You can make the value of your subscription endpoint whatever you want, as long as your Apollo server uses the exact same value so that it is actually a valid endpoint. And the falsy case of this ternary operator, meaning that the window is actually undefined, we do not want to create a WebSocket link because WebSockets are not available on the Next.js server. So we just want to make the value of WebSocket link null. Okay, so let's scroll down to the section of the documentation where they're doing this split link logic here. Again, we are basically going to be doing exactly what they're doing in the docs here with some minor modifications to make it work with Next.js. So we're going to have to do some similar logic here to check for the existence of the window object. So I'm going to create a variable called link. And again, we're going to need to create a ternary operator to check the value of the window object. So we can say if the type of the window is not equal to undefined and the WebSocket link is not equal to null. So if all of this is true, it means that we are not on the Next.js server and we are indeed in the browser. So it is safe to create a split link using the WebSocket link. If this is true, we want to make the value of our link exactly what they have indicated in the docs here. So we can just copy this entire split statement here and paste that in the truthy case of this ternary operator. And in the falsy case, meaning that we are on the Next.js server where WebSockets are not available, we only want our link to be the HTTP link. So let's save that. And we just have to import a few things here. So let's import all missing imports. So make sure the split function imports from Apollo client and the getMain_definition function imports from this Apollo client utilities directory. And the very last thing we need to do is just pass this new link object here to our Apollo client. So rather than the HTTP link, we are going to pass in this link, which is going to be this new split link that includes our WebSocket link. And this concludes all of the changes we need to make to our Apollo client. So our front end is currently set up to support WebSockets. So let's head on over to our backend index file here, and let's now configure our Apollo server to support WebSockets and GraphQL subscriptions. And very similar to what we did with the Apollo client, we are going to head on over to Google and search for Apollo server subscriptions and go into this documentation here. Okay, so this is going to be our first look at subscriptions in GraphQL. So as the documentation states here, we can use subscriptions to get real-time updates on our client whenever a particular server-side event occurs. So GraphQL subscriptions use WebSockets under the hood to enable this long-lasting connection between the client and the server, which allows us to perform real-time updates. Chat applications are probably the most popular example of real-time functionality. As the docs state here, for example, a chat application server might use a subscription to push newly received messages to all clients in a particular chat room. And that is exactly what we are doing. So in any GraphQL application where you want real-time updates to occur on your client without the user having to refresh the page, you're going to need to use subscriptions, which use WebSockets under the hood. So I recommend you to visit this documentation here and give this a read if you are interested in hearing more about subscriptions and how they work. And if you go through this documentation here, there is a step-by-step guide that tells you exactly how to enable subscriptions in your Apollo server. It talks about what packages you're going to need to install, and then it takes you through a step-by-step guide to build your server to allow for subscription. And at the very end here, there is a completed example showing the entire server setup to have WebSockets and HTTP both enabled for your GraphQL server. So ours is going to look pretty much exactly like this here, just with a few minor differences, particularly surrounding the context and the way we're going to set up context, but I'll speak more about that when we get to it. Okay, so I'm just going to shrink this back. And the very first thing we're going to do is go and install the packages that we're going to need for our Apollo server GraphQL WebSocket setup. So let's come up to step 1 here and copy this installation command. And now we want to create a new terminal window in our backend directory and run this installation command. So we are installing the GraphQL WebSockets package, the WebSocket package itself, and I actually think we have already installed these two packages here. So I think these two WebSocket packages are the only new ones we are grabbing right now. So let's come back down to the completed example here, and I am just going to not copy the entire thing because we have a few differences here. Okay, so let's start off with the section here where they are setting up the Apollo server. So this is what ours currently looks like. So what I'm going to do is just copy and paste this plugins section here because that is going to vary with subscriptions being enabled. So we can take that and paste it in here. And I'm going to import all the missing imports in a second here. So the only difference between this Apollo server and our Apollo server is the context here. So the next thing we're going to do is create our WebSocket server. So let's copy and paste this new WebSocket server instance they have created here. And let's put that just under our HTTP server. And if you remember on our front end, we created this HTTP link as well as this WebSocket link. And I was telling you about how on our server, how we were going to set up this new endpoint for our WebSocket link. That is essentially what we are doing here. We are creating a new WebSocket server for our WebSocket link on our front end to communicate to on our API. And if you remember on our client, we changed the value of our subscriptions endpoint to this value here. So we can just take that and paste that here. So rather than just GraphQL, we are going to have /GraphQL/subscriptions. Okay, another thing we're going to need to add from this documentation example here is this server cleanup function here. So let's grab this and we can just paste it under our schema here because our schema is going to be passed in. So let's grab these two import statements here, WebSockets server as well as userver, and paste them in here. And yeah, I think we're going to need to install these types. So sometimes in a TypeScript file, if you do not have the types installed for a particular library, you will see these little 3 dots under the library name here. So if you hover over it, it will basically just tell you to try installing the types for that library, and it will usually give you the command to do that. So let's copy this command here, come over to our terminal in our backend and install those types. Okay, awesome. And then this gray squiggly line should disappear. Perfect. Okay, so I'm just going to shrink this down again. One other thing we're going to need to configure with our WebSocket server is our GraphQL context. So currently, the way our context is set up with our Apollo server, we will not be able to access this context in any of our subscription resolver functions. If we want access to our context inside of our subscription resolver functions, we are going to need to add a context to this useServer function here. So inside of this useServer function, inside of this first argument object here, in addition to our schema, we can also pass a value for our subscription context. Okay, so let's declare this, and the value of this is going to be a callback function, very similar to what we were doing down here, where we are going to be able to build our subscription context. So this callback function is going to accept an argument called context, which we are going to call CTX, and this context is going to be of type subscription context. And we're going to create this interface right now. So let's head on over to our backend types file here, types.ts in our util folder, and let's head on up to the top here. And I'm just going to create a new comment that says server configuration, because we're going to have a few types here. So our GraphQL context is going to be server configuration. I would actually say our session is also server configuration, so I'll put that there. So just underneath our session here, let's create that interface for our subscription context. So we can call this subscription context. So the way context works with GraphQL subscriptions is a little bit different than what we've seen before with this context declaration here on our Apollo server. But essentially all we need to do is declare what are called connection params for our subscription context. And on those connection params, we are going to have our user session. And we are going to want this interface to extend the default GraphQL WebSockets context interface. So the context we are wanting here is not from Apollo Server Core. Let's come up to the top here, and we want to import this context from the GraphQL WebSockets library in the directory lib, and then in the server file. So from here, we can import the context interface, and that is the interface we are extending down here. So if you click into this, and this is kind of intimidating to look at, but the only part of interest to us is this connection params here. So as you can see by this comment, it is saying that connection params are the parameters passed during the initial connection initialization. So what that means is that when our Apollo client first establishes a connection with our Apollo server, we can send data along with that initial request through this connection params value here. And one of the pieces of data that we want to send in this connection params value here from our Apollo client is the next auth user session. So the way we can do that is back in our Apollo client.ts file here, inside of this create client function, as a second configuration value, we can set the value of these connection params. So the value of this is going to be an asynchronous callback function. So whatever we declare and initialize in this callback function here is going to be passed to our Apollo server on the initial connection here. So whatever we put inside of here is going to be available on our backend through this connection params on this subscription context. So as I just mentioned, we want to pass the user session. So the way we can do that is we can declare a value for the session, and to get the value of our user session, we can use our getSession function from NextAuth. So make sure that imports at the top here from NextAuth React. And now when our Apollo client first connects with our Apollo server, we are going to have access to the session in our subscription context, meaning that we will be able to access the user session in our subscription resolvers. And it is kind of unfortunate and a little bit confusing that the setup for context for our HTTP requests and our WebSocket requests are a little bit different, but that is how it works. And in order to access the context in our subscription resolvers, we need to configure the context in this way. Okay, so let's go back to our types here. And we are saying that we are extending the context, which we were just looking at here. And we just want to add the session to the value of our connection params here on this new subscription context interface. So we can open up a set of curly brackets, and we just want to specify the type for our connection params value. And this is going to be an object with a session inside of it, which is going to be optional because it's not always going to exist because a user might not be signed in. And the type of our session is going to be our session type up here. Okay, so we can close this GraphQL library file here, and we now have our subscription context interface defined. So if we come back to our index file here, we should be able to import this from our util types file. And let's specify the return type of this context callback function. So the structure of both our subscription context and our HTTP context are both going to be the exact same, and they're both going to be of type GraphQL context with those three things on it: session, Prisma, and PubSub. But just the way we set up the session with the subscription context is a little bit differently, and we just had to add this connection params function here in our Apollo client to send the session. Okay, so let's come inside of this function here and actually build out our subscription context. Okay, so down here where we are creating Prisma, you can see that there was a comment we added called context parameters, where there's going to be Prisma and PubSub, which we're going to bring in just a second here. I'm just going to move this up above here so that we can reuse Prisma in our subscription context here. So you can see that due to our new subscription context interface, we have type safety here. So we can access the connection params, and on the connection params, we can access the session. So what we want to do is check if there is a session on our context. So we can say if context.connection params and context.connection params session, we want to destructure the session from our context connection params. So we can grab the session here, and actually, sorry, this callback function here for our context is supposed to be asynchronous. So let's add the async keyword here. And the value of the context we want to return, which is going to be of type GraphQL context, is going to have that session inside of it, as well as the Prisma client. If there is not a session on our connection params, the value of the context we are going to return is going to have a null session, but it's still going to have the Prisma client on it. So this would be the case where a user is not signed in and there is no user session. So the very last thing we need to do to wrap up the setup of WebSockets and subscriptions is to bring in that PubSub library here. So now we are going to create our instance of PubSub. Okay, so if we go over back to the documentation here on the same page we were looking at before with the subscription setup, there is a section called the PubSub class. So this section here talks about what PubSub is, and it talks about the publish subscribe model. So PubSub is short for publish subscribe, and that is the model that PubSub uses under the hood. But basically the way the publish subscribe pattern works is throughout our code, when certain things happen, we can publish events and send data along with those events. And then inside of our subscription resolver functions, we can listen to those events and take the data that was published and do something with that data. And you might remember me briefly talking about this in our conversation resolvers. I was saying how when a conversation is created inside of our create conversation mutation, we are going to publish a conversation created event using PubSub. And inside of a subscription resolver, we are going to subscribe to this event, meaning that every time this event is published, the subscription resolver is going to be fired, and we can do something with the data payload, which in this case is going to be the conversation. So we are going to be creating a subscription called ConversationCreated, which is going to be subscribed to this conversation created event. And then we will be able to take the data that is sent along with that publish, which is going to be this conversation, and we can send that data to our client React application, which is how these real-time updates occur. And so that is basically how the publish subscribe pattern works. You basically just publish events when certain things happen, and then you can subscribe to those events in these subscription resolvers and then do something with that data. All right, so hopefully all of that makes sense. Let's shrink this down a bit. And what we're going to do is install this library here, GraphQL subscription. So let's copy this command, and in our backend directory, let's run that installation. Now, creating our PubSub instance is extremely easy. We just literally need to add these 2 lines of code to our server over here. So just underneath our Prisma client in our context parameter section, we can create a new variable called PubSub, which is going to be a new instance of the PubSub class, which doesn't want to auto import. So I'm just going to copy this import statement over here, come up to the top, and add that just under our Prisma client. And now we have created a new PubSub instance, and we are going to want to add PubSub to our GraphQL context because we're going to need it across all of our resolvers. And we have this comment here that I created a long time ago. So let's actually add this in here now. And the type of this is just going to be PubSub, which again doesn't seem to want to auto import. I don't know why auto import's not working. We can use that same import statement here. Awesome. So now PubSub is added to our GraphQL context. And TypeScript is mad over here because we are not adding it to the context. So let's make sure we do that. PubSub and PubSub. And same thing down here. Awesome. So I think that concludes our server and client setup for subscriptions. So let's go to our running server and see if it's alive. Okay, so it's successfully running. It didn't break. So that means everything that we have written is valid. If you go to our front end and we refresh this page, hopefully there are no issues. Okay, so the server seems to be fine. The client is fine. We're not seeing any errors. So we should be good to go. And we can now create GraphQL subscriptions so that we can get real-time communication between our server and a client. And so now that we have all of this set up, we can go back to our conversation creation flow and actually publish this conversation created event and create that conversation created subscription resolver function. And that is how we are going to get new conversations to appear in real time on our user's front end. So to create our new conversation created subscription, we are going to need to declare it in our conversation type definitions file here. So creating a type definition for a subscription is pretty much the exact same as creating a type definition for a mutation or a query. However, we are just going to declare it as a subscription type rather than a query or mutation type. So just underneath this query here, we can create a new subscription type. And inside of here, we can indicate the name of our subscription. And in this case, it's going to be ConversationCreated. So our ConversationCreated subscription is going to be responsible for passing a newly created conversation entity to our front end. So we are going to declare the return type of the subscription as a conversation. Awesome. And that is how easy it is to declare a new subscription in our type definitions. So we can close this and come back to our conversation resolvers here. All right, so we are back in our create conversation mutation. Now let's actually use our PubSub instance to emit this conversation created event, which that new subscription that we just created is going to subscribe to. So let's come up to the top here. And now that PubSub is available on our context, we can grab it from the context up here. Then down here, just underneath this comment, we can use our PubSub instance and call a function called publish to publish this specific event. The first argument to this publish function is going to be the actual name of the event we are publishing, which is going to be this conversation created event. And the second argument to this function is going to be the data payload. So we want to pass an object with the name of the subscription as a key, and the name of the subscription is conversation created, and the data we want to pass to this subscription is this newly created conversation entity. So we can just make the value of this conversation, just like that. And now what we can do is actually create the subscription section of this conversation resolvers object here. We have query and we have mutation. We do not yet have subscriptions. However, we are now ready to do that. Okay, so just underneath our mutation object, let's create our subscription object. And just like our queries and mutations, this is where we are going to declare all of our conversation-related subscriptions. All right, so I'm just going to quickly go back to the documentation here for subscriptions in Apollo Server. And the section we are interested in is listening for events, because now we have successfully published this conversation created event. And now we actually want to subscribe or listen to this event in our new subscription so that our subscription fires every single time this event is published. And this is exactly what this section of the documentation talks about here. So essentially, another method available on our PubSub instance is called async iterator. And the docs explain that an async iterator is an object that listens for particular events and then adds them to a queue for processing. And then it basically says that every subscription resolver must return an async iterator object. And then they give an example down here, how they have this subscription called post created, and then they have a subscribe function that returns an async iterator instance with the name of the event that this particular subscription is listening to. All right, so in this subscription function, we want to declare our new conversation created subscription. So the value of this is going to be an object, and inside of here, we want to declare this subscribe function, just like they're doing in the documentation. And this is going to be the callback function where we're going to call that async iterator method on our PubSub instance and indicate what event we want to listen for in this particular subscription. Now, in order to call this async iterator method, we need access to our PubSub instance from our context. So very similar to what we were doing with the arguments of our other resolver functions, we can do the same thing for the subscription resolver function. So the first argument, which is the parent, we are not going to need. So we're just going to declare it as an underscore of type any. Second one is going to be our args, same thing, not going to have any args to the subscription. And the third one is going to be our context. And the type of this is going to be our GraphQL context. Now inside of this function, we can destructure PubSub from our context, just like this. And now we can call that async iterator method on our PubSub instance and listen to that event. So we can say PubSub.async iterator. And inside of here, we want to pass an array. And in this array, we want to indicate that we are listening to the conversation created event. So now when the create conversation mutation is fired, this conversation created event is going to be published with a payload with a new conversation in it. And since our conversation created subscription is now listening to that event, this subscribe function is going to fire every single time this conversation created event is published. Now, the whole goal of creating this subscription is to get our server to pass this newly created conversation entity to our client in real time as conversations are created. Now, in order to do that, we actually need our React application to subscribe to this subscription. So that is what we're going to need to do next. We're going to need to go to our front end and have it subscribe to this subscription so that our subscription can actually send this data to our React application in real time. All right, so let's head back over to our front end and specifically our conversations wrapper component, because this is where we are actually going to fire off the request for this conversation created subscription. And I just briefly want to go over to the subscription documentation for Apollo client. And the section I just briefly want to discuss here is where we actually execute a subscription. So when you want your React application to execute a subscription, there are two ways you can do it. The first one is by using the useSubscription hook, which is very, very similar to using the useQuery or useMutation hook, where you pass in a subscription query string, and it works very, very similar to the other hooks that we have seen. And the other way you can execute a subscription is by subscribing to updates for a query. And this basically means that if you make an initial query for some sort of data and you want real-time updates to that query's original result, then you can use this pattern here to receive those updates via some subscription. And essentially how this works is the useQuery hook, in addition to these three parameters here, actually returns another function called subscribe to more. And through this subscribe to more function, you can subscribe to a particular subscription on your API, and then that subscription can send real-time updates to update the original result of this query. So essentially, your initial query would receive this data as a result, and if an update occurs on the server that would actually change the result of this query, we can receive those updates through this subscribe to more function so that this data value actually updates in real time. So which one of these two methods you use to execute a subscription sort of depends on the subscription and what you want to do with the data that the subscription provides. So in the case of our conversations query here, it makes sense to use this subscribe to more function because we make this initial request for the user's conversations, and then we want real-time updates to that user's conversation, and we want them to be added to this conversation list as they are created on our server. So essentially, the initial value of conversations data is these two conversations here, but let's say some other user creates a new conversation with this user here that we're logged into in this browser. We can receive that new conversation so that it appears here in our UI through this subscribe to more function. And throughout the course of this entire build, we are going to be using both of these methods multiple times. We're going to be using the useSubscription hook as well as the subscribe to more function. It's going to vary depending on the use case, but in the case of our conversations query, we are going to execute our conversation created subscription through this subscribe to more function. All right, so if we scroll down in the documentation here, it kind of goes through how to use this subscribe to more function. In this example in the documentation here, they are subscribing to real-time updates to the comments on a particular post. And so they define this function called subscribe to new comments. And this function essentially just calls this subscribe to more function. And through this document input here, they are indicating which subscription they are actually subscribing to, which in this case is this comment subscription, which is defined up here as this GraphQL query string. Okay, and I'm just going to expand this out a bit so we can see the full thing. And then there is this callback function called updateQuery that is going to fire every single time the subscription receives new data, and that data is going to come in through this subscription data value here. And then they take that new subscription data, and then they use this object.assign function to essentially add that new data that came in to that query's original result so that the data object return from useQuery now contains those subscription updates from the server. And that is how your data is going to be updated in real time through subscriptions. And in the case of updating our conversations in real time, it's going to look very, very similar to this example they have in the documentation here. So let's collapse this back down. So I'm just going to scroll down here just so we have a reference to the documentation example here. And let's come over to our code. So we are going to create a function called subscribe to new conversations. And inside of here, we are going to be calling that subscribe to more function. And this function is going to take an object as an input, just like they're showing in the docs here. And the first thing we need to do is actually pass in a subscription GraphQL query string to this document input here to indicate what subscription we want updates for. And we have actually not yet defined the query string for the subscription. So let's head on over to our conversations operations inside of here, and we can create that subscription query string right now. So inside of this subscription object here, we want to create a new query string called ConversationCreated. And again, we can use our GQL function with the double backticks. And this query string is going to be a subscription, so we can use the subscription keyword. And we can name this ConversationCreated. And inside of these curly brackets, we want to indicate the name of the subscription resolver function on our API, which is going to be ConversationCreated. And the data we are going to query for and receive from this ConversationCreated subscription is going to be a populated conversation, which has the exact structure of this ConversationFields object that we defined up here. So we can go ahead and reuse our conversation fields, because that is the exact structure of the data we are going to get from this subscription. Perfect. So now we have a subscription query string, so we can close this. And the document we want to pass in is going to be conversationoperations.subscriptions.conversationCreated. The second argument they pass into their subscribe to more function is this variables parameter here. However, in our case, for this particular subscription, we do not have any variables, so we do not need to worry about that. So we can go ahead and add this updateQuery callback function. And this is going to receive two arguments. It's going to receive the previous value of our data. And the second argument is going to be an object with the new subscription data inside of it. And then we can open up a new function here. And you can see in the documentation here that they are returning this new object here. So whatever is returned from this update query function is going to be the new data that this query is going to have. Okay, so you can see that they are using this object.assign function. And basically what this does is it takes two objects here, this prev as well as this new data object, and it basically merges them into this object here, which is going to be the value of this whole object.assign function call. And the reason they do this is to safely merge these two objects without directly mutating state. All right, so let's indicate that we want to return this new object. So we can say object.assign. The first argument is going to be this empty object. The second one is going to be the previous value of state. And our third argument is going to be an object that is going to represent what we want our data to look like after inserting the subscription data into it. So we are making updates to our conversations data, which is called conversations. And we want our conversations data to be updated to include the new conversation from this subscription data. So what we can do is take the previous value of conversations and spread it so that we're including all of the conversations that already exist. And then at the very front of this array, we want to add in that new conversation from the subscription data. So we can say subscription data conversation created. Now TypeScript is giving us an error here that's saying conversation created does not exist on type conversations data. So we need to fix the typing of this object here. Okay, so the type of this is going to be an object with this subscription data inside of it. And the value of subscription data is going to be an object with data inside of it. This data is going to be an object with the conversation created subscription name inside of it. And the value of this data is going to be an entity of type conversation populated. So we want to import that type there, save this. And in a second here, we're going to strip this out and create an interface for it in our types util file. But for now, we'll just leave it like this. Just above our return statement here, we want to add an if statement to make sure that valid data is being received by our subscription. So we can say if there is no subscription data, we want to just return the previous value of our state. If there is valid data, we want to create this variable called the new conversation. And this is going to be equal to subscription data.conversation created. This represents the conversation that our server is pushing to our client through the subscription. Now down here, we can change the value of this to be new conversation. So we are taking this new conversation and prepending it to this conversations array so that our conversations data is now going to include this new conversation. So that concludes our subscribe to more function here, and it looks very similar to what they're doing in the documentation, but we haven't actually executed this subscription yet. We haven't called the subscribe to new conversations function. So what we want to do is just simply call this function as soon as this conversations wrapper component mounts to the DOM. To do that, just underneath it, we are going to create a use effect with an empty dependency array, meaning that this is only going to fire one single time on component mount. And when the component mounts, we just want to call our subscribe to new conversations function. Awesome. So I'm just going to add a comment above here that says execute subscription on mount. So now what's going to happen is as soon as this component mounts, this useQuery hook is going to fire, and we are going to get the initial value of our conversations data. And also on component mount, we are calling our new subscribe to new conversations function, which is going to call our subscribe to more function to actually execute this subscription, so that on our backend, when this subscription fires due to this conversation created event being published, we are going to receive that new subscription data through this update query function here. And our data state is going to be updated in real time to show that new conversation. All right, so I think we have done everything we need to do in order to actually get this to work. Okay, so before we test this out, let's just throw in a couple console logs to see the value of things at certain times. throughout our code execution here. Okay, so one of the things I'm going to log is going to be our query data, because I want to show you how this is going to update through our subscription. So we have query data. This is going to be conversations data. Okay, the other thing I want to log is this subscription data down here. Here is subscription data. Okay, and we just want to show subscription data, which will contain the new conversation. Oh, okay, and it looks like I have another here is data log that already exists down here. So let's remove that because we just added one up here. So I'm going to open up the database here. We currently have 3 users, Shadbud, LolDude, and Shadman. And I think I'm currently logged in as Shadbud over here. So what I'm going to do is open up another browser. I'm going to open Firefox here. I don't think you can use 2 windows in the same browser and have 2 different users due to the session. I think you have to use 2 separate browsers. So I always have like Safari, Firefox, and Chrome open. All right, so let's create a new user here. Oh, okay, I only have Shadmerhi available here. I actually think I've used all my test Google accounts for authentication. What should I do here? Because I want to create a new user. You know what I might do, honestly, is just wipe the entire database. Yeah, let's wipe the database, and then I can show you how to wipe the database if you ever need to, using this Mongo shell command line here. And you can run commands in here on your database to like wipe out entire collections, so you don't have to manually delete each document here, which I used to do before I knew what the Mongo shell was. Okay, so I don't use this super often, so I think you can run something like show DBs or something, or show DBs, and it will show you what databases you have. Okay, and then I think you can use the keyword use and then the database you want. Okay, so we're already in iMessage GraphQL. So I think to wipe a collection, what we can do is we can just say db.user.delete many, and then we just want to pass in an empty object here. So if I run this, yeah, it will tell you how many it deleted. So there's 3. So if I refresh this, there's now no users. And we just want to do the exact same thing with all of our other entities. So accounts, delete accounts. Okay. Oh, and you can use the up and down arrows to go to previous commands. So we want to wipe accounts. We want to wipe sessions. Whoops. Okay, we want to wipe conversations and conversation participants. Whoops. Cool. Okay, so now we have a completely empty database. We can close that. And we have nothing in here. So if I refresh this page, this user is going to be logged out because they don't exist anymore and they don't have any conversation. So the session is back to null. Okay, so in Firefox here, I'm just going to select shadmerhi@gmail.com because it's the only one available. Enter my new password. Okay, 2-factor auth. Okay, I'm just going to cut this out of the video. Okay, so I just created a new user with shadmerhi@gmail.com, and I'm going to name this person Firefox because we're in the Firefox browser. Okay, cool. So now we have Firefox logged in over here, and in Chrome, I'm going to log in as one of my test accounts, and I'm going to name this person Chrome. Very creative names. So what we're going to do here is, as Firefox, I am going to create a new conversation with Chrome. And if our subscription is working, we should see that new conversation appear in both users' conversation wrapper components in real time. So let's give this a go and see what happens. So I'm going to click Find or Start a Conversation. I want to search for my friend Chrome. Click Select, and let's give this a go. Okay, so that did not work at all. Why not? Okay, so something's not working with our subscription. If I refresh this, that new conversation should appear, but that's not the behavior we want, obviously. We want these things in real time. Okay, so something's going on with our subscription. I'm not too sure what, so I'm going to look into this and come back in a bit here. Okay, so I think I found the problem. I'm on the backend inside of our conversation resolvers file. I think in our conversation created subscription here, we simply need to return this PubSub.async iterator. So I think by simply calling the method, it doesn't actually register the subscription. I think you have to return the async iterator. And I actually think I remember it saying that in the docs. It says, where does it say that? I know it says it somewhere. Search for return. Return. Okay, yeah, here we go. It says the subscribe function must, bolded. It is bolded, meaning that they knew people like us were coming. They knew that Shad was going to forget to return the thing. That's why they bolded it. Okay, so I think that should fix the problem. Let's see though. I might be wrong. We might have other deeper issues. I'm going to go back to our database and just simply wipe conversations and conversation participants. No need to wipe our users anymore. Let's wipe our conversation participants and let's wipe conversations. Okay, so if I refresh both of these browsers now, Firefox and Chrome, there are no conversations for either of them. So let's try this again. Let's have Firefox search for Mr. Chrome, select, and let's see if this works. Okay, it still did not work, which is super sick. It seems like our subscription still is not firing. So this was not the problem. So I don't know what's going on. This is weird. I'm gonna have to do some digging. Hey guys, I just wanted to give you a heads up that the next chunk of the video is going to have pretty poor quality audio. I ended up running into some issues with saving the initial audio recording, and I just couldn't save it, and it was being super weird. So I couldn't figure out another way to do it, so I used my phone to record the original audio playing through my computer. So it's a recording of a recording, and it just doesn't sound that great. So I do apologize for that. I was just unable to save the audio and just wanted to give you a heads up. Okay, so I've literally been debugging this for the last hour, I think. I don't know how much time it's been, but it's been probably an hour. It took me a while to figure out what was going on. I finally found out basically what was happening was that our subscription was not firing. And I could not figure out why. I thought it was an error with the Apollo client establishing a WebSocket connection with our server, but I found out that wasn't the problem. But essentially what happened was I figured out that there was an error inside of this conversations field array that I created before. So it's fixed now, but if I Command Z this file here, all the way, I essentially had this declared in the incorrect way. Okay, so this outermost conversations object is not supposed to be here. And it was preventing our subscription from happening because the structure of the fields that we were querying for did not match the data that we are allowed to query for on our API because of this outermost conversations object. Our conversation created subscription data does not have this outermost conversations object. And when the structure of your query strings from your front end does not match the structure of the data defined in your typeDefs on the back end, your subscriptions, I guess, just won't fire. And you don't really get an error telling you that that's the problem. They just don't work. So yeah, that's why it took so long to figure out, because there's no error message saying that there's like a discrepancy between what you're querying for and what you're allowed to query for. It just literally doesn't do anything. I figured out that this was just declared slightly wrong. So we don't want this outermost conversations object, so we can strip this out and remove this outermost conversations object and just paste in the fields here, which do not want to auto format. So let's tab them in a few times. And then down here on our conversations query, we do want that conversations outermost object, because that's the name of the resolver function for this particular query. And inside of here is where we want the field. So that is my bad. I did not notice that when we were creating this conversations field. So once I removed that outermost conversations object, the subscription seems to work. Okay, so let's try this whole thing again. Our little testing demo here. So we have Chrome on the right and Firefox on the left. So let's try to create a conversation with Mr. Chrome. And this should work. So keep your eyes peeled up here, and we should see this update in real time. So create conversation, and we do. And you can see that the subscription is firing. I'm just gonna zoom in the console here. So we logged, here is subscription data, which is happening inside of this update query function in our subscribe to more function. And we can see that if we go into here, there is data. Inside of data, there is conversation created. And inside of conversation created is the new conversation. Awesome. So that should be working now. Again, my apologies with that error with the conversation fields. I honestly missed that when we were writing these out. Awesome. So our subscription is successfully working. The conversation created function is firing, and through PubSub, we are able to relay this new conversation entity to our client in real time, which is super, super cool. Okay, so the real-time functionality is working. However, we have one small problem with the logic of our subscriptions. And that problem is this subscription is going to fire for every single connected user to our server. And that means that every single user is going to get hit with that subscription data on their client. Even if they're not in the conversation, this is literally going to blast every single connected client with the subscription update. And I'm sure you can tell that that's obviously not good, because we do not want random conversations that Chrome is not in to just be appearing in Chrome's browser. That'd be really weird. Okay, so to demonstrate this, I'm going to quickly open up Safari and go to localhost and create a new user. Hopefully it's a different email. Okay, yes, it is. Okay, I have to enter my password. Not now. I never use Safari, so I don't care about the password storage. Let's name this guy Safari. Wow. Safari, Mr. Safari. Okay, so to demonstrate this problem that we have with our current subscription logic, if Safari were to create a conversation with Firefox, Chrome is also going to get updated with that conversation, even though Chrome is not in the conversation. Not good, obviously, but to demonstrate that, let's take Safari and make him create a conversation with Firefox. Chrome is clearly not in this conversation. It's between these two users, but Chrome is going to get hit with that update anyway. So let's watch this happen. Okay, so you can see how Chrome was hit with that update. His subscription fired. Not good. We need to fix this. Okay, now luckily, this is a very common scenario when you're working with subscriptions, and Apollo solves for that problem with this function called withFilter. So I'm going to expand this out a bit, and there's a section in the documentation here called filtering events. And basically it explains exactly our problem. And then it goes through a similar example to us, and it basically talks about the same issue that we're facing here. It's saying that the comment added resolver executes for every new comment, regardless of which repository it's added to. And it's saying, as a result, subscribing clients might receive data they don't want or shouldn't even have access to. So again, the exact same problem we are facing with our conversations. Mr. Chrome could see the conversation between Safari and Firefox. That is not good. So we can solve this problem with the withFilter function. So basically, when using the withFilter function, you can write some logic in here to return a Boolean. And that Boolean, true or false, is going to represent whether or not you should push an update to a specific client. So in their case, they are verifying that the newly added comment repository name is equal to the subscription variable's repository name. In the context of our chat application, we only want to emit updates to a particular client if that client is in the conversation that was just created. So in our withFilter function, what we can do is look at the newly created conversation, which is going to be available to us on this payload object here, and we can look at the conversation's participants and see if a participant entity exists with a user ID that is equal to the ID coming from the user session. If that is true and the connected client is indeed part of the conversation, then we will publish this event to that client's browser. All right, so let's shrink this back down and build this withFilter function and solve this bug that we have just discovered in our app. Let's go back to our code here and go to our conversations resolvers. And we're going to be looking at this ConversationCreated subscription. So we are going to need to change the structure of this up a bit here. So what I'm going to do is just comment this out. And down here, I'm going to basically rewrite this. All right, and I'm actually just going to open up the documentation here. So we have some reference. Where was the filtering for events? Filtering events, here it is. So the syntax of ours is going to look slightly different than this because we are using context and they are not, but it's going to be quite similar. So for our subscribe function, we want to call that withFilter function. So let's import this from GraphQL subscriptions. The withFilter function takes in two arguments. The first one is going to be the callback function that is responsible for calling the async iterator event on our PubSub. And the second one is going to be a callback function that is going to receive the subscription payload and the variables as an argument. And inside of it is where we're going to write the logic and return a Boolean that represents whether or not we should publish this update to the connected client. So our first argument is essentially going to be this thing here, this callback function. So I'm going to copy this and paste that as the first argument. And this is very ugly to look at right now, but bear with me. Let's comment that out for a sec here. And the second one, let's make a just empty callback function for now. Save that and it should format. Okay, so in the first argument, we have this callback that is accessing our context so that we can call our async iterator function on our PubSub to subscribe to that event. This second callback function is going to receive the payload, the variables, as well as the GraphQL context. Our first one is going to be our payload. The second one is going to be the variables, which we do not care about in this case because we don't have any variables for the subscription. So I'm just going to declare it as an underscore. And the third one is going to be our context. So for the types of these, let's declare this as our GraphQL context. For our payload, we are going to come down here and declare an interface called ConversationCreated Subscription Payload. That is a long name. And we will eventually move this to our types util file, but let's just do this here for now while I explain this withFilter section here. So the structure of our payload is going to be an object with the subscription name as a key. So we have ConversationCreated, and the value of this is going to be an entity, which is going to be of type ConversationPopulated. Okay, and so let's declare our payload as type ConversationCreated subscription payload. TypeScript is freaking out because we're currently not returning a Boolean in our function here. So inside of this function, we are going to destructure our user session from our context. So we want the session. And we are also going to destructure our conversation participants from our payload. Inside of this object, we want to destructure the conversation created object. And inside of here, we want to destructure our participants because that is really the only piece of data on our new conversation that we care about in the context of this function. Because we're going to check if there is a participant that has a user ID that is on this session user's ID. So now let's create the Boolean that we're going to return from this function. So we are going to call this Boolean user is participant. And to determine the value of this Boolean, we want to search through this participants array and see if we can find one with the user ID that matches the user ID on the session. So we can say participants.find, and we want to iterate through each participant and see if we can find one where the participant's user ID is equal to the session.user.id. And we are just going to Booleanize this by adding the double bang operator here. And we want to return user is participant. As I said before, if the signed in user is a participant of this conversation, this is going to be true. So we are going to be returning true, meaning that we are going to indeed emit this event to this particular user. If this user is not a participant, like in the case of Chrome a few seconds ago, we are not going to emit this event to that user. Okay, so that should conclude this logic here. So I'm going to remove this comment. And now what I'm going to do is wipe our database once again and see if this solves the problem. So let's go over here and wipe conversation participants, wipe conversations, and let's refresh all of our browsers here. Refresh Firefox, refresh Chrome, and refresh Safari. So now we have 3 users connected to our server. We have Safari, Chrome, and Firefox. So what I'm going to do is use Safari to create a conversation with Firefox. And before we just added that withFilter function, we saw that Chrome was receiving that update as well, which was incorrect. With the withFilter function, Chrome should no longer receive that update and only Firefox should. So let's see if this works. Perfect, so it does. So only Firefox got that update because he is in the conversation, and you can see that Chrome was not hit with that subscription because he is not in the conversation. So the logic seems to be working, and we no longer have users looking at conversations that they are not a part of. So thank goodness for the withFilter function, because that is a critical piece of functionality that we need in our app. Okay, so we are done with that terrible audio. I was just editing that clip, and it was tough to listen to that audio throughout the duration of editing that. So again, I apologize. Do not know what happened with QuickTime Player when I was trying to save that audio. Hopefully it does not happen again, because that would suck. So now that our conversation created subscription is working and we can successfully create conversations with other users and get those updates in real time, the next thing we are going to focus on is going to be the conversation item component that we've already sort of built out the skeleton for. That looks like this, where we're just currently showing the conversation ID. Now we're actually going to add the majority of that component now so that we can actually have a nice UI element to look at rather than just an ID. Okay, so currently Chrome has no conversation, so we should probably create one. So let's use Firefox to do that, just so I can work in Chrome. Create a conversation with Mr. Chrome. We get that update in real time. And this is the current state of our conversation item, which is this component here. So our conversation item component is a bunch of just stack components and Flexbox containers. It's It's just a bunch of HTML that we've kind of already seen throughout this tutorial. So what I'm going to do, just in the interest of time, is just paste in the bulk of the HTML from my demo project, just because I don't think it's the best use of time to just have you guys watch me build a bunch of stacks and flexbox containers and stuff. So I'm just going to paste that in there. The important parts of the component are going to be the onClick functions that are going to exist within it, like when you edit a conversation or delete a conversation. Those are going to be the parts that I'm going to focus on the most after building this out. But as for the actual HTML structure, I'm just going to paste that in from my demo. And I will be sure to put a link to this component in my GitHub repository so that you can easily just go and grab that code and paste it in there as well. Okay, so I'm going to copy everything over and paste it in here. Okay, so it's quite lengthy, and we need to install this datefns package and create this format usernames function. So what I have done is just commented out all of the stuff that is going to be coming in the future, like all of these click handler functions, like on edit conversation, on delete conversation, etc. And so I've just commented out those things throughout the component so you can kind of see where they're going to be used to give you some, I guess, foreshadowing for what's coming in this component. And there's a few things we have to add here. But yeah, this is the main structure of this component. And one thing I'm actually going to walk us through right now is this onClick function, because that is going to be the function that is going to be called when a user actually clicks on a particular conversation item component to have them be able to switch the conversation they are looking at. And we are going to define that function in our conversations wrapper component. Okay, so in our conversations wrapper, above this subscribing to new conversations function, we are going to define this new onClick function called onViewConversation. So this is going to be the function that is called when a user clicks on one of their conversations. And this is going to be asynchronous. And this function is actually going to take in an argument called conversationID. And this is going to be the ID of the conversation that the user clicks on so that we can make the necessary updates. This function is only really going to do two things. The first one is going to be push the new conversation ID to the router query params using the Next.js router. And that is going to trigger another data fetch so that the messages for that conversation can be fetched and displayed on the screen. And the second thing we're going to do is mark the conversation as read. So when a user clicks on one of their conversations, if it is unread, we are going to send a request to our API to mark that conversation as read. And that logic does not exist in our application yet. That will be coming in the future, but I will leave this comment here for now so that you can understand what's going to be going on in the future. What we can do now, though, is push the conversation ID to the router query params. I'm just going to remove some of these console logs here to keep this a bit cleaner. Get rid of the query data. Is there any other logs in here? I don't think so. Here is subscription data. Let's get rid of that. Okay, so let's bring in our Next.js router. Underneath our useQuery here, we can use the useRouter hook from next/router. And the first thing we want to do in this function, just underneath this comment, is simply do router.push. And we want to push this conversation ID to our query parameters, just like that. All right, so this is all we need to do inside of this function for now. And as I said, in the future, when we build out the functionality for marking conversations as read, we will come back here and finish off this second part. Okay, and this is actually supposed to be on view conversation, not conversations, because it's a single conversation we are clicking on. Okay, so let's come down to our conversation list component here, and let's pass this in as a prop. So the third prop we're going to pass here is going to be on view conversation, and this is going to be equal to that new on view conversation function we just defined. Now let's come into our conversation list component here, and let's add that to our props interface on view conversation. This is going to be a function that takes in an argument conversation ID of type string, and it's not going to return anything, so we can just declare the return type as void. Okay, let's add that to the destructured props here on view conversation. So let's come down here to where we are iterating through all of our conversations. So one of the props we are missing is going to be our onClick function, and this function is going to call that onView conversation. So we want to have our onClick function call onView conversation and pass in the conversation ID of the conversation that we are currently iterating through. And the last prop that we are missing for now is this isSelected Boolean prop. And this prop is going to be used to apply conditional styling to this component so that we can indicate on the UI that it is indeed selected by making the color of the background different if that is true. In order to determine if a particular conversation is selected, all we need to do is check to see if the conversation's ID is equal to the ID of the conversation that is in the URL query parameters. So again, we can bring in our Next.js router. So at the top here, let's declare our router and bring in our useRouter hook. And I'm actually going to put it under here, under these onClose and onOpen functions. Then let's come down here, and we want to make the value of this isSelected Boolean the result of if the conversation ID is equal to the conversation ID inside of the router query parameters. So we can say if the conversation ID is equal to router.query.conversation ID. And we also want to pass in our user ID to the conversation item, because that is going to be used in our format usernames function. So we have the session in here. So underneath the router, let's grab the user ID from the session. So we can destructure that like this, destructure the user, and on the user, we want the ID, and we're going to alias this as user ID. And then we can just pass this in like that. User ID is equal to user ID. Okay, now TypeScript is happy here. We have passed in all the declared props that we have defined on our conversation item, except for these ones here, but they're commented out, so they don't really exist yet, but they are coming soon. Okay, our conversation item component is very angry still because we have a few TypeScript things in here. Okay, latest message body. Why is this complaining? Property body does not exist on message. Property body does not exist on latest message. So conversation. So this conversation should be of type conversation populated, which has a latest message on it, which should have a body. That's like the main part of a message. Okay, why is that? Did we add the body to our schema? So if we go to our Prisma schema and we look at the message entity here, oh, we actually don't have a body declared here. How did I miss that? That's like the main part of a message. My bad. That is my mistake. So yeah, the reason that we were getting that TypeScript error over there is because we did not actually add the body to our message model in our database. So our conversation populated type is actually missing the body. So to fix this, it's easy. We can just, below our sender here, we can just declare a message body, and this is going to be of type string. And since we made a change to our schema, we now have to run that npx Prisma generate command once again to update our Prisma client and all of the TypeScript types, which conversation populated is part of. So let's open up a new terminal window in our backend directory here, and let's run that command. Npx Prisma generate -- schema, and the path to our schema is source/prisma/schema.prisma, not /prisma, schema.prisma. Run that command. That is going to generate a new Prisma client, which should update the type here. So this should have a body on it now, and yes, it does. Awesome. Okay, and so now the only error we have in here is from this uninstalled library, well as this utility function here, which we're also going to define. Let's define the utility function first. Okay, so do we have a, so we haven't actually created that functions file yet. So in our front end directory here, in our util folder where our types file is, let's create a sibling file called functions. So these are going to be like utility functions. Okay, and what I'm going to do is paste in the format username function that we're going to use. Okay, and again, I will put a link to this file in the description. All this function does is it takes in the conversation participants and it formats them in a nice comma separated list. And it also filters out ourselves because we don't want to see ourselves. I don't need to see myself in there. So we filter ourselves out, and then we create this nice comma separated list. And if you're not sure what I'm talking about, it will make more sense once we build out the rest of our conversation item component. Okay, so that should solve this. We now have this format usernames function, which is being used here. And the last thing we need to do is install this datefns library. And datefns is essentially just a really nice library for like time and date formatting, and it allows you to very easily take dates and format them in pretty much any format you want. It's pretty insane. If you look at the docs, you can do like really anything you want. We're using this to display exactly what time the message was sent. So like 11:12 p.m. or 8:53 a.m., whatever. So it's a super useful library, highly recommend it. All right, so we need to install this in our front end. So let's create a new terminal window for our front end, and let's install datefns, npm I datefns. And this is a really, really popular library. If you're curious, you can go to the npm datefns page here, and I'm sure it has like millions of weekly downloads. Yeah, so 11.6 million weekly downloads. That's pretty insane. Very popular library. Highly, highly recommend you to check it out. Now that we've installed that, we are no longer facing this issue. And what is happening here though? Docs, messages. Do we just have to recompile our front-end directory? Let's try that. We're going to restart the development server and see if that solves this. I'm not sure if it will though. Okay, so I think that solved that weird error we were just seeing, but we now have a new one here. Invalid time value. What line is that on? 140. Conversation updated at. Do we have an updated at? Dot updated at. Why is that mad? Honestly, every time I work with dates, I have to dive deep into them every time. I never remember anything about dates. I don't know if I'm the only one. So all you have to do is create a new date instance with the conversation updated at. Did not have to do that in my demo project. Not sure why that's happening here. I'm going to look into that after, and if I find anything, I'll let you know. But it seems to be working. And you can see here that we now have this nice conversation item component. Okay, so I think this is only happening on this little bit of screen size. I think if you go out a bit, it looks a lot nicer. And then on mobile, it just goes to this. Okay, so what I want to do though is fix it for this. Okay, so what I'm going to do is for this text here that represents our time text, I'm just going to add absolute positioning to it. So I'm going to make the position equal to absolute. And I'm going to make the right value, so the spacing from the right side of the container, I'm going to make equal to 10. What does that look like? Okay, that's a little intense. Let's try 2. Okay, 2 is better. Okay, let's try 4. Awesome, so that is sort of the chunk of our HTML of this component. And this was the username thing I was talking about, where it has the comma separated list of all the users in this conversation. So to demonstrate what this looks like a little bit better, let's create a conversation with Firefox and Safari. So there's 2 people in it. Create conversation. And yeah, you can see that both usernames are there. So you can see that when I click on a conversation, it updates to be selected, which is good. That means our onClick function is working and we have this styling applied. And the ID is changing in the URL query parameters, you can see, and that's good. One thing I'm not so sure about is why this isn't taking the full screen width on mobile screen sizes here. This should not be appearing right now. Okay, you know what I think we're missing? I think we are missing some styling on our feed wrapper component. I thought we added that, but let's go look. Feed wrapper. On mobile screen sizes, if there is a conversation ID, we want to make the display flex. Okay, you know where I think our error is on the conversations wrapper component. Yeah, I think we need to add a media query here to the display. We want to add a similar media query to the one we saw on our feed wrapper. On mobile screen sizes, if a conversation is selected, we don't want to show our conversations wrapper component anymore. We want to just show the feed with a back button, which is very similar to our real native mobile experience. So what I'm going to do is basically copy this media query on our display from our feed wrapper and paste it on our box here. Like that, and I don't think we have a conversation ID yet. So we can destructure the conversation ID from the router query parameters. We already have the router here, so just underneath that, let's destructure the query and then the conversation ID, save that, and that should now be working. And let's move this to the top here. It's kind of like the governing CSS class. So now if I go down to mobile screen sizes, it's still showing. Why? Medium flex, if there's conversation ID. Okay, we need to negate this. We want this to be none and this to be flex. So if there is a conversation ID on mobile, we do not want this component to display. So this is correct now. If I expand this out to a medium screen size, it will show. And if I go down to mobile, it will only show the feed. Okay, awesome. So we just have to add that media query to our conversations wrapper. Now I'm actually going to add the feed wrapper component at the top of the feed here. That is going to display the usernames of the users in the currently selected conversation, as well as that back button that will allow users to go back on mobile here. Because right now you can't really deselect this conversation without modifying the URL, but that's obviously not what we want our users to do. We want to add a back button. So that component is going to exist in our feed wrapper here. All right, so what we're going to do is modify this flex container here, because that is this right now. We only have the conversation ID in there. So let's make this a bit more meaningful. So on this outermost flex, let's add some CSS properties. The first thing we're going to do is add a flex direction of column, and then we're going to make the justified content value equal to space between. we are going to add an overflow property of hidden so that our feed container can actually be scrollable. And we are going to give this a flex grow of 1. And let's give this a border for now so we can see what we're looking at. Okay, so we can get rid of this conversation ID, and we are going to have two components inside of this flex container. We are going to have a component called messages header, which we have not created yet, but we're going to in a few seconds here. And the other component is going to be our actual messages component, which is going to be sort of like the bread and butter of the feed. It's going to be responsible for querying for the messages in a particular conversation and displaying them on the screen. So this messages component is probably the most exciting component of our entire app, and we will probably create this in the next part of this series. Right now, though, I want to create this messages header component. So let's come into our file directory here. And inside of our feed folder, I'm going to create another folder called messages. And inside of here, I'm going to create a file called header.tsx. Now, again, for this component, I am going to paste in the code for this from my demo project, just because it is just a bunch of stack components from CHAKRA, and we've already seen that stuff. So I don't really want to spend time writing out a bunch of CSS for stuff that we've already seen, because that's not the most exciting part. So what I'm going to do is grab all that code and paste this in here. And it's not a super long component. It's only about 30 lines or so. And again, I will put the link to this component in the description, so be sure to check for that. So let's save this here and address the issues that we have. So we have this skeleton loader component. So let's comment it out because that is going to be coming soon. And conversation operations. Why is this not importing? Operations, conversation. Oh, change the name. Okay, what else is in here? Skeleton loader. Okay, so we don't have our loader components yet, so let's comment that out. We should be good to go. So in this component, again, we are using that format usernames function to show the usernames of the currently selected conversation at the top of the screen there for a nice little UI component. And we also have that back button that I was talking about that the user can click on to remove the conversation ID from the router query parameters so that they can go back to their conversations list if they are on mobile. As you can see, we have this media query here on the display property, because on medium screen sizes, we don't really need a back button because we can see these conversations. So only on mobile, we need that, which is why we have this media query here. Okay, so let's come back to our feed wrapper component here, and let's bring in this messages header. And we want to import this from messages/header. And the two props we need to pass to this component are going to be our user ID and the conversation ID. So we have the conversation ID already, and we have the session from props. So let's destructure the user ID from the session. User and ID alias as user ID. Then down here, let's pass the user ID and the conversation ID. Perfect. And this is complaining why? Type string or array of string is not assignable. Oh, okay, this is like a classic query parameter issue I have with Next.js. Okay, so technically the URL query parameter could be a string or an array of strings, and we have defined it as a string here. In our case, it's always going to be a string. It's never going to be an array of strings in our application. So what we can do to solve this TypeScript error here is just add another check to this ternary operator logic up here. We're going to say, is there a conversation ID, and is the type of the conversation ID equal to string? And that will remove that TypeScript error, because now TypeScript knows that in order for this to be rendered, this must be true, meaning that the conversation ID must be a string. Perfect. And so now up here, you can see this very nice component. You can see to Firefox. I click on this, to Firefox and Safari. And this is, again, that comma separated list of the usernames that I was talking about. And if we go down to mobile, the back button shows. And if I click back, we are now back at our conversation screen. If I click on one, the feed is there, back. Very nice. The only thing we have to do is remove this ugly 1 pixel solid red border and we are good to go. We added our message header, and we can get rid of line 31 here. And I'm going to leave this comment here because that is coming soon, and that is probably the most exciting component of this entire build. All right, you guys, I think I'm going to leave it there for part 3. We have covered a ton in this video, and we have finally implemented some real-time functionality into our app. We got our WebSocket link and WebSocket server all set up, and we learned about GraphQL subscriptions and how to create them. And we got our ConversationCreated subscription working so that users can create conversations with other users and have those updates appear on the UI in real time. And we have gained such a strong foundational understanding of all of the complicated parts of this build that I think the future parts are going to go much faster, and we'll be able to just get more and more practice and repetition with these concepts. And we're going to build out a ton more React components and more GraphQL subscriptions and get the whole messaging logic built into our app. So that is it for now. Please leave a comment if you have any feedback on this tutorial series, and like the video if you did enjoy it. It really does help out the channel, and subscribe if you would like to. And also, please do join my Discord. The link is in the description. I would love to see you in there. Thank you guys so much for watching, and I will see you in the next one.